All right, welcome back, everyone. Make sure that we are unmuted. Very good. Okay. Welcome back, everyone, to our PRA Realism Workshop. We're going to kick off our post-lunch session with a session on realism for advanced reactors. We have Marty Stutzky, who's going to provide the NRC perspective, and then we have Eric Thornsbury from EPRI, who I believe will be joining us remotely with his presentation. So Marty, if you could take a minute and tell us who you are and why you're here, and then go ahead and do your presentation.
Yeah, I'm Marty Stutzky. I'm the Senior Level Advisor for PRA in the Division of Advanced Reactors and Non-Power Production and Utilization Facilities. Much easier just to say DANU, and that's part of the Office of Nuclear Reactor Regulation, or NRR. So with that, when Michelle first contacted me to give this talk on PRA Realism and Advanced Reactors, I immediately thought of the Italian mathematician Bruno Di Finetti. In the preface to Di Finetti's book on probability theory, he wrote in all capital letters, "Probability does not exist." Well, how the heck can you talk about the realism of something that doesn't exist? That's a joke, okay. So by way of explanation, Di Finetti was arguing that probability is not an objective feature of the world, but a subjective measure of your personal belief and ignorance that exists only in the mind. Now, it's not my intention to follow Di Finetti and all the others down that philosophical rabbit hole like Alice and Wonderland, but rather to try to adapt a more pragmatic and engineering-oriented point of view that considers how well the PRA estimates the risk metrics of interest and how well the PRA represents the plant as it's being designed, constructed, and operated. And so to bolster my position there, I'll quote from a December 2024 article in the magazine Nature. It was written by a guy named David Spiegelhalter, who's an emeritus professor of statistics at the University of Cambridge in the United Kingdom. And he wrote, "In our everyday world, probability probably does not exist, but it's often useful to act as if it does." So with that, let's flip to the next slide here. So how does all of these topics relate together like that? And let me repeat the background that we need to consider these topics for advanced reactors. We're talking about a variety of reactor technologies: sodium cooled or liquid bismuth cooled fast reactors, high temperature gas cooled reactors, heat pipe cooled reactors like this, anything from large base loaded units for electric power generation. For example, the Kemmer construction permit application is a large sodium fast reactor. Reactors that could be used to generate process heat. We have an application in-house for the X-Energy and Project Longmont. It's in Seadrift, Texas. And it's being designed primarily to provide process heat to Dow Chemical. Okay, so that's something really different. All the way down to so-called microreactors. So an example would be the Westinghouse eVinci. So think about this. You're going to build the reactor in a factory. You're going to load the fuel in it. You're going to test it out. You're going to put it on the back of a truck, roll it down the highway, plug it in. Okay, that is a really different critter than we're normally used to dealing with like that. Make it even more complicated, we can talk about the role of the operator in these new designs. Part 53 introduced this notion of what's called self-reliant mitigation facility that could be staffed by generally licensed reactor operators that perform no safety functions. We could talk about remote and autonomous operation of reactors like this. So the types of scenarios that we need to think about in the PRA are outside our experience based as PRA analysts. I mean, yeah, we have the tools, we have the standards, but until you put it into use, it's a daunting task when you think about it. So, okay, next slide. The first thing I thought we'd chat about a little bit are the commission policies and how they relate to PRA realism. And I'll emphasize up first, policies are not legally binding. They're not regulation. However, the commission issued an advanced reactor policy statement first in 1986. Okay. It's been revised several times since then, but let me set the stage for this, 1986. That is several years before Part 52 was even issued. Okay. The Clinch River breeder reactor construction permit was completed. I actually worked on that PRA. It was the second one that I had ever done in my entire life like this. Also of note is the modular high temperature gas cooled reactor from General Atomics, roughly the mid to late 1980s, something like that. MHGTR is interesting because I consider it as the grandfather of today's licensing modernization project. You can go in there and pull out, they have a frequency consequence curve, the idea that you could use the PRA to inform the safety classifications of system structures and components. Think about it, late 80s, okay? Like that. So the Advanced Reactor Policy Statement talks about using PRA to minimize the potential for severe accidents, and it points over to the Severe Accident Policy Statement. And when you look at that policy statement, half of it's devoted to future plants, not current plants. We think of the Severe Accident Policy Statement as kind of the kickoff for the old IPEs and IPEEE process. But the commission's focus was on not just currently operating fleet, but new plants as well. The Advanced Reactor Policy Statement also references the commission's safety goal policy statement like this. And one of the things that or perceptions that I have is that when people think of the safety goals, at least some of the newer designers, they tend to think of them as the boundary between adequate protection and something that's not acceptable. Like that. That's not the case. The safety goals define how safe is safe enough. The way I personally think about it is the safety goal is a stopping rule. My risk is so small that I'm willing to live with it. I don't need to do any more like that. But so forth. The Advanced Reactor Policy Statement also says PRA should be used as a design tool, and it points to the PRA's policy statement, which when you pull that one up, it says PRA evaluations in support of regulatory decisions should be as realistic as practicable. Again, that buzzword, realistic, like that. So I'd argue there's a long-standing consensus that realistic and useful risk insights can be developed for advanced reactors. But there are struggles involved. We'll talk about some of those in the coming slides. So, next slide, please. So I've tried to outline some of the licensing pathways and how they relate to PRA realism. We're all familiar with Part 50, the two-step application from construction permit proceeding to operating license like this. Part 52 has a variety of vehicles in it, from standard design approvals, manufacturing licenses, design certifications, leading to combined license, things like that. There is a rulemaking that's been underway for a number of years to align parts 50 with 52 that would require PRAs. There's currently no PRA requirement in Part 50 for either the construction permit or the operating license. Also, what's not on the slide deliberately is I haven't mentioned Part 53. It's currently with the commission now, and I don't want to get ahead of their decision, as well as the review by the Office of Information and Regulatory Affairs, part of the OMB. But they have Part 53, as you know from the preliminary rule, has the same frameworks like this. But in general, one could argue the PRA's realism increases, improves as you go from left to right across the diagram. In other words, by the time you reach the operating license stage, or you have the field load PRA for combined license holders, you have the actual design. It's as built, it's occurring operating experience like that. Next slide, please. One other thing that needs to be considered is PRA acceptability. And Adrian had spoken a little bit about this topic earlier. So what I've done here in the table, the left-hand column are the attributes of PRA acceptability that are from Reg Guide 1.200 and Reg Guide 1.247. Remember, 1.200 is the LWR version, 1.247 is currently for trial use, and it applies to non-LWRs. But it talks about the scope of the PRA is defined in terms of the metrics used to characterize risk. Okay, well, what if you're using risk surrogates? Okay, that might be acceptable to reach regulatory decisions, but you're not actually calculating the risk of interest. Common example is we use core damage frequency for large light water reactors. And we argue that's a surrogate for the individual latent cancer fatality quantitative health objective. When you look at the numbers, it's actually quite conservative like that. So you're not actually calculating the risk of latent cancer fatality like that. You have problems when you define risk surrogates and you try to transport them over, like core damage frequency. What is the core damage frequency of a molten salt reactor? The core is already liquid by definition. So core damage doesn't make a lot of sense. You can come up with interesting risk metrics like the failure of the first barrier that provides defense in depth. Other types of risk surrogates, such as large early release frequency, may make sense. It tends to be, in my mind, a more technology inclusive type of phrase, but that doesn't mean that 10 to the minus 5 is the right number for other types of reactors like that. Second line on there talks about you need to consider radiological sources, the plant operating states, and the causes of the initiating events, the hazard groups like this. And ideally, you would consider all of those things like this. But at various points in the licensing process, you may have, for various reasons, decided some things screen out, or you're going to defer it and treat it later in the licensing process. For example, for plants coming in under LMP and Reg Guide 1.253, Appendix A, it talks about the minimum PRA would be a reactor at power internal events PRA. If an applicant wanted to do more, do the screening analysis for the other external hazards, that's fine like that. But again, the point is, until you do the whole spectrum there, you don't really know what the risk is. You're missing something. Okay, so level of detail in the model. Again, the resolution of the modeling used to represent the behavior and operations of the plant. You're doing detailed modeling or simplified modeling? Some of the earliest PRA work that I saw for the Kairos plant was nothing more than an event tree with some numbers on the branch points. Okay, you can learn a lot from that, but it is, we'd all agree, a pretty simplified model like that. And it was just one event tree for all initiators. So, with more detail becomes, of course, more work, but more insights like that. The elements of the PRA referring to the various technical analyses, plant operating state analyses, initiating events, data analysis, HRA, et cetera, like this. And Victoria brought up a very good point this morning. Are you doing conservatism? Are you deliberately inserting conservatism in your model? That's a tactic that you might use if your goal is merely to prove that you're going to meet the quantitative health objectives, but you're distorting the risk profile, as she pointed out, like this. So you might miss something like that. The other thing that I've thought about a great deal is, how do you know you're conservative? Okay. It kind of implies you know what the right answer is, and then you add a margin on top of it, but that's not necessarily the case. We may, rather than to build a PRA model with event trees and fault trees, use alternative methods like seismic margins analysis. We already accept that for large light water reactors, or the older EPRI 5 study, the fire-induced vulnerability analysis. But those do not produce risk estimates. They're designed to show you that the risk is acceptable by some criteria. So how realistic is your PRA if you're using these things? Then there's the possibility of various approximations that could be in any one of the technical elements, like this. Last and not least, plant representation and PRA configuration control, and that was talked about this morning for the operating fleet. The idea, again, is how closely does the PRA represent the plan as it's being designed, built, and operated? And my experience and my instinct says, the PRA always lags the actual plant design like this. So one of my personal fears is I'm reading something in the PRA chapter, and to get more information, I go to another chapter of the safety analysis report and find out what the PRA model and what they describe elsewhere in the SAR don't align. We've had some indications of that in some of our applications like this. PRA analysts didn't know, so they made an assumption. Things like this. Then later you say, well, it's here, why didn't you model it? So these things are interesting puzzlements. Moving on to the next slide. Non-LWR PRA standard and realism. I should point out the non-LWR PRA standard addresses all radiological sources at the plant, all the plant operating states, at power, all the low power shutdown, all of the hazards, internal events, internal floods, internal fires, seismic, all there. And it is what is called a full scope. So it goes from the initiating events to the consequence. If I were talking about LWRs, I would say, oh, it does level 1, 2, and 3. But they don't use that language for non-LWRs. Everybody talks about the level 3 analysis, and we all know they mean radiological consequence. So think max, those types of things like that. Anyway, we know the standard is broken into a set of technical elements and sub-elements, and what I'll term are programmatic elements. PRA configuration control, peer review. And the nature of the standard is that it defines high-level requirements, both technical as well as a set of documentation requirements. And to demonstrate that the high-level requirements are met, there's a set of supporting requirements like this. And the user of the standard should go through the supporting requirements and decide which ones apply to his or her application like that. Now, the non-LWR PRA standard has what I call qualifiers written into some of the requirements. It'll say, prior to operations, do this, or for operating plants, do that. And the implication is, well, if I'm not an operating plant, then I don't have to do that, like that. So there is a process in the standard to go through and identify which supporting requirements are applicable to your application, like that. Then, as we know, PRA standards divide supporting requirements into various capability categories. The idea being the higher the capability category, the more the PRA scope is, the level of detail is deeper, the plant specificity is better, and hence the realism is better. But when you actually look at the standard, there are only about 22% of all the supporting requirements that differentiate between category 1 and category 2. 78% of them, it's the same requirement for both capability categories. So how much more real is the PRA if I require category 2? Okay, well, it could make a big difference. You're down to details at that. Next slide, please. Lack of operating experience. Since my work in Dana, I've heard a lot of, I won't say complaints, but concerns by staff and industry about the lack of operating experience. How are we going to quantify this PRA? Things like that. I'd point out, first of all, a lot of the operating experience from the current fleet could be applied to new and advanced reactors. Right? A pump is a pump, a valve is a valve, like this. And that relates to the notion of what's called data exchangeability. Now, that phrase, exchangeability, actually goes back to DeFinetti, as I mentioned in my introduction. And the idea is the component has an identical design and the same operating conditions, then that older reliability data should still apply, like this. New Reg 2201 makes that assertion that says at the component level, exchangeability is probably pretty good, like that. I should also point out, you're not necessarily constrained to information here in the US nuclear fleet. One could use foreign data. Why not? French operated sodium cooled fast reactors for years. We can lay hands on that information. That would be useful. In the early days of PRA, we used non-nuclear data. Gary might remember the old Arita database from Norwegian oil platforms that we used. It's an excellent database. So there's probably more information out there than people realize, but it's getting our arms around it. And it's not just the staff, but the applicants need to get it. As a fallback, one can consider the use of expert elicitation techniques. Excellent book, New Reg 2255 provides guidance on how to do expert elicitations like that. And the notion is basically trying to capture the center and the body and the range of the uncertainty distribution about this. Of course, formal expert elicitation can be a little pricey. Appreciate that. Like that. The inset is a quote out of the famous paper from Kaplan and Garrick, where they define the risk triplet. They talk about statistics is the way of the science of handling data. Probability is the way of handling a lack of data, like that. So one question, I'll give industry a little heads up so they can mull this over. But one thing to think about during our discussion later this afternoon is we currently have an infrastructure that says plants belong to INPO and they contribute all of their failure data to the ISIS system, the INPO Consolidated Event System. Well, suppose the plants aren't going to join INPO. These tiny microreactors may not be interested or don't see the bang for the buck. So now we're not getting the data. So how's that going to work? Just need to think through it. Okay, and so last and not least, appreciative of time, is ultimately the staff's got to reach a regulatory decision here. And as indicated before, we need to consider the role of the PRA in the application. And by that, I mean, is the PRA being used in a more leading role to help design the plant, such as the licensing modernization project? Or are you merely trying to show there aren't any severe accident vulnerabilities like this? Another good point that was brought up this morning is the use of importance measures, sensitivity analyses to focus on what is important. Now, there's a little twist in the non-LWR world. Most folks are familiar with what are so-called relative importance measures. Fussell-Vesely, risk achievement worth, things like that. And as a disclaimer, Jerry Fussell was my advisor in grad school. So I'm a little biased towards the use of the Fussell-Vesely measure like that. But they're relative to the baseline risk. For example, so they're normalized by core damage frequency or largely release frequency. On the other hand, absolute importance measures are normalized by the target risk. Okay, so if I were to use absolute importance measures for core damage frequency, I would divide everything by 10 to the minus 4. That's target risk. The result is when you use absolute importance measures, not so many things are as important. In fact, nothing could be important because you've screened them all away like this. Whereas relative importance measures, there's always something at the top of the list. Like that. So I've been contemplating that for a number of years. Finally, there's this notion of using defense in depth to compensate for the uncertainty in the PRAs and the lack of PRA realism. I think Fernando gave us a great talk earlier this morning about all the considerations of using defense in depth. My somewhat sarcastic view is I have a cut set and I want it to go away because it's driving my answers. So I'm going to add features to the plant to ensure that cut set moves to the bottom of the list, things like that. He had mentioned the paper and the work that was done on the structuralist versus the rationalist view of defense in depth. And one of the key questions in the paper is how much defense in depth is necessary and sufficient? A real good question, and I don't have an answer. I think it does come down to individual cases like that. So finally, in closing, I'd put in this inset here some thoughts from former Commissioner Apostolakis he made at a PSAM conference a number of years ago in Honolulu. That's basically, it goes back to this notion of the state of knowledge is key. What do we really know regarding the design, the operation like this? Where did we get that information from? Science, engineering, operating experience? How exchangeable is that information to us? And ultimately, PRAs are used to evaluate and assess the accident scenarios to inform the decision maker's state of knowledge. And those decision makers are not only the regulators like me, it's the people designing the plant. It's the people that are going to buy this design and use it. Okay, so everybody's involved here, and they all have somewhat different perspectives. But ideally, if the PRA is real, we'll all come to a consensus. That concludes my remarks.
Okay, thank you. Let's go ahead and go to Eric. Eric, are you with us? You should be able to unmute, show your screen, do whatever you need to do.
Yes, I am, and I can see myself on
Excellent.
your screen. Let's see, that should do it. Switch to there. All right, I think that'll work. Thank you. I am Eric Thornsberry. I'm a principal technical leader at EPRI. One of my main responsibilities right now is to lead our research into risk analysis methods and tools for advanced reactors. And I also continue to work on risk and safety management topics for the current fleet as well. So I have a nice tie between the current fleet and what we refer to as the future fleet. So today I'll provide a bit of an update on some of the research we've been doing recently and are looking forward to in the near future related to the technical basis and the realism in our PRAs and our risk analysis. So we started this several years ago, building off of what we already know with the use of PRA and all of our risk methods and tools for the current fleet, which have developed nicely over the years and continue to still grow in their realism, subject to ongoing work as was discussed this morning. But as we've started to look toward the advanced reactors and future plants with different technologies, we wanted to understand where we are in terms of all of these components of the technical basis of PRA and how ready those are to support those advanced reactors. So we sort of baselined that, and then we looked at, well, what are the challenges that we're going to face with the new reactor designs, identify what those technical gaps could be, and then start researching them and start to hope to close some of those gaps and improve the realism in our analysis techniques. So that's what we started with. And then over the last few years, as I said, we've made some progress on some of the key areas, and I'll talk about those as well as some other things that we're still working on. I kind of set this up with some questions and answers. How ready are the risk analysis methods? That's kind of was our first question that we started with. And so that initial research is documented in this report. I think this one's freely publicly available, so we can kind of see what some of the challenges are and where various organizations, not just EPRI, can start to advance the research and advance the state of the art in terms of PRA. So that's out there. And then we started diving into more specific questions. So Marty even mentioned, if you're talking about core damage frequency, that might not work for all or many of the new plant designs. So what if you can't do that? How do you approach your PRA and the resulting risk metrics in a way that can be technically valid and bring some consistency across all of the different types? So I'll talk about this a little more in the next few slides. But so this is the report that's out that supports that. But what we did to answer that question is we tried to go back and look at what NRC has done as well as others around the world, and understanding really how we ended up with CDF and LERF and the safety goals and how they're related and what the connections were between those, and then try to figure out what's the most important aspect we want to capture with those risk metrics. So we wanted to focus on public safety. That's the job of the owners, the operators, the regulators. Everybody should be focused on that as the outcome of the risk analysis. Secondly, you can see we wanted it to be technology neutral. So we wanted it to apply to all types of plants. And from building it from the top down, that makes sense that we want that to be able to work. And then looking across the world, as EPRI supports certainly the United States, but also clients around the world and regulators around the world are starting to work together more and more. So we wanted any approach that we suggested to be internationally applicable. And so as we looked at those key characteristics and looked at the technical details of risk metrics, we came up with this approach that we think takes those key characteristics and then focuses them into a primary safety metric that's focused on that public safety concern, and that we can measure at what point is the public impacted, and then how do we respond to that impact. And then from there, we can kind of move to the left and to the right. This is impacting the public, but we like to know about things before they get that far. So we developed some guidance to help the development of preventive metrics. And so at some point, if the public's going to be impacted, there has to be some sort of loss of control, or, in a current reactor we talk about, that's when core damage occurs. We're no longer containing the radioactive materials in the solid fuel, they start to melt. So that's our preventive metric, and then we track it to see it get outside of the plant, which kind of gets us back to the middle. But if we focus here first, we can build these preventive metrics that can be very different across different plant designs, whereas the yellow box in the middle can be common to all plants. Then if you move to the right, we say, well, we still want to take this safety metric and relate it to our higher level safety objectives in the United States, the quantitative health objectives, for example. And so again, a plant specific or a design specific calculation would probably be needed to show that once there is some threat to the public safety, how does that actually translate into latent cancer or early fatality sorts of risks that the QHOs deal with. And so there's this central portion that should apply to all reactor types. And then to the left and the right, you get a more plant-specific or design-specific approach that takes into the account the details of that design. So that approach, we think, it's very consistent with what's already been done and used, although we have to just think about it a little bit differently with some of the different plants. So that was published just over a year ago. To address the details of that approach, we suggest something like this, where it's an offsite dose emergency action frequency. It's a longer term, but we're thinking, okay, well, the public is impacted when there's some sort of dose that gets offsite that creates the need for some sort of action on the part of the public. And so this would be doing a PRA, finding all the accident sequences that lead to some sort of dose offsite at the boundary, beyond the boundary of the plant, and for some specific time, because we have to get all of those variables in there. So for example, we could use something like a 50 millisievert dose at 4 days from an event. That one works because dose is independent from reactor design. All of our nuclear technologies, that's what the NRC is protecting against, is dose to the public. So that's independent, so that'll work for everybody. It kind of gives us a realistic measure of potential offsite impacts. If it's below that level or whatever level is chosen, we're saying that that's negligible enough that the public doesn't have to take action. And there are other programs in place, not PRA, severe accident related, that deal with normal operational exposures and accidental exposures at that level. So those are separated. And we're used to using dose in existing regulatory requirements. So that works out pretty nicely. As I said, we look around the world. IAEA uses this particular dose number. The protective action guidelines from EPA, I believe, have a range of actions that start in that range for different responses to an event. So it kind of works out nicely to use that number, although that number could be changed and defined more specifically in different locations. So it does focus on public safety, and it focuses about, as I said, it talks about where is that need for offsite response. If it's negligible and below that, yes, it has to be dealt with, but it's not a severe accident that we deal with in PRA. So that's where we want to focus on the protection of the public. If you're going to use this metric or any sort of metric, we'd still want to stick with those best estimate consequences. And that's where that realism question comes back into play. With some of the PRAs that we're used to, as we transition to the PRA models for the new reactors, we still need to make sure that we're doing our event trees, our fault trees, and our end state assignments in a way that's realistic. With some of the designs, it may be still okay. On some of the branches, you can still be simplified, or I hate to say conservative, but maybe simplified is the better word, where it's clearly, obviously below a limit or clearly, obviously above a limit. We can easily assign the end states to that, but there are going to be places where it's going to be close. And so that's where the realism in the thermohydraulic modeling and the radionuclide transport modeling still have to be refined and acceptable to help us identify those and calculate those in our PRA models. So the boundary can be defined, again, by the licensing and the regulator. All the hazards and all the sources could fit into this as appropriate. We're not saying everything has to be put into this, but where necessary, if a PRA models a specific hazard or source, it would work with this common metric. And it does focus on that PRA purpose to address those low frequency, severe accident sort of scenarios that are more high consequence. The opposite is dealt with through other methods with the regulator. And it does draw that line where the regulatory concern is above this limit. So let's quantify that. What are the sequences in the accidents that actually lead to something of regulatory and public health safety concern? So that's one of the areas that we started off trying to help with some realism into the risk metrics for advanced reactors. If we go back to my Q&A slide, one of the next big things that came up was passive systems. So the safety of many of these advanced reactors makes greater use of passive safety systems where they don't rely on external power or a driving force of some sort that's external that may not be available. With the passive systems, you're relying on gravity or heat differences or pressure differences to drive the cooling in an emergency. So what experience do we have for that? And this has been a question around for a while because it's not completely new, but there is a new focus on it. So first we looked and evaluated what's out there, and then we put together some recommendations for how to try to address these approaches more realistically. And the second one came out of the first because, as sort of a teaser, the first one didn't always reveal a lot of realism existing already. That first phase, we evaluated, we looked a lot of good research from around the world even to look at reliability assessment methods for these passive systems. There's regulatory experience going back to like the AP600, AP1000 that have some passive systems. The new scale has been licensed with their design certification. It has some passive systems in there. A few other countries have also done similar experience. So, we kind of consolidated that. We looked at what experience exists in experimental facilities and testing and identified what the key issues were and what the capabilities were. And they're pretty good, but we still felt that there was some additional guidance needed. For the record, these are some of the approaches that we reviewed. A lot of them focus on identifying these critical parameters for the passive systems and looking at how those could lead to a situation where the passive function no longer works. Because we're not talking about a failure of a diesel generator or a pump to run. Now we're looking at, well, what situations could arise that prevent the passive cooling function or whatever the passive function is. With new plants, there's a little bit less operational data and experience, some cases a lot less. So expert judgment still has to be relied upon, and that's how the current fleet grew. At first, there's more expert judgment. As more operational data and experience is gained, those can be weighed against each other and strengthen the argument. But we recognize that at first, a lot of the advanced reactors will have to have a mix of these, including some expert judgment. So it really comes down to, and I think this is consistent with some of what Marty said, it's an uncertainty assessment. How confident are we in the ability of the system to function. So it's not a structural probability, but more of a subjective probability. And so we have to be able to analyze the uncertainties that are there, assess their realism, and how can we simplify the model to still reflect it accurately without overcomplicating the question that we're trying to answer. So this gets into some of the more details of our passive system work. I don't necessarily need to share, but you do need to get that realism in your thermohydraulic computations so that you can assess what happens when things are a little bit out of whack. The very good thing was we found a lot of this good information. One of the challenges is that in a lot of the literature and the examples, there's a wide range of what we would judge as realism. Some had very, very, very low numbers. Some had very kind of high numbers for reliabilities. And some were not really always done in a more in a realistic setting, very sometimes academic or experimental. And they all had value, but pulling them all together in our work, I think, will hopefully help move the ball forward a little bit and help with the process. So realism really is that key to turn what exists into a practical approach. And so in phase 2, we did that. We've produced this guidance for sort of a common realistic approach with a realistic demonstration using a very simple system. It was still a water-cooled based system because that's a little more familiar to both the analysts and the readers. But it walks through a process where you assess the hardware reliability aspects, the operator reliability aspects, as well as the thermohydraulic reliability aspects of it, and brings all of those together into what we hope advances the realism of the assessment of the passive systems. All right, a few other items that we've worked on recently is reliability integrity management. So that's an ASME code-based approach to taking care of your passive components like vessels and tanks and piping in a plant. The RIM, the reliability integrity management, is a PRA-based approach to it, or informed approach, but it relies on the PRA as an important input into it. And so there's some initial guidance and some ongoing work where we're participating on both the code activities and some examples with some current plants to look at that aspect. Another realism question that came up is, what about when I have an advanced reactor design and maybe my internal events have designed the plan in such a way that those internal events likelihood is very, very low. And the most likely thing that happens is actually a very rare but external event. So how do I think about those risk insights from a realistic perspective? Because, the meteor strike was mentioned this morning, I think. There's always something where you can raise the stakes or raise the hazard, but how do we approach those and how do we think about those? So we did an example using seismic events to kind of think about how do we realistically assess risks when what's important is not what we're used to seeing as important in internal events, but it might be something external. And then we continue to work on a couple of other aspects. This hazard and consequence analysis is for digital systems. Digital INC, as Fernando mentioned, is an important issue. This isn't unique to advanced reactors, but it's a nice overlap between the current and the advanced reactor designs that are using digital systems. So how do we use PRA and risk in a smart way, in a realistic way, to help digital system design? We have a strong human reliability research program that's continuing to look into aspects such as digital systems or such as unique situations for advanced reactors, and that is continuing this year. Severe accident analysis, as I mentioned, the thermohydraulic modeling, you need to have the appropriate amount of realism. And so trying to help advance the technology for modeling accident scenarios for advanced reactors is also ongoing at EPRI. And then one of the ones that I think overlaps with some of the previous conversations nicely is data needs. And so this is a project we're we're diving deeper into this year in terms of what do we really mean when we say uncertainties and realism in data for advanced reactors. So it's things like what needs exist? Do we need better component failure likelihoods? Are there other databases, as Marty mentioned, that maybe we can tap into and use, and how relatable are they? It's not necessarily this applies and this doesn't apply, but it might kind of apply. So how do we use the information that's available to make more realistic judgments to lead to more realistic decisions? The system performance is mentioned there. And again, going back to, as Fernando said, for the decisions that we have to make, how do we deal with these uncertainties when maybe there is limited operational data? We've been through that 50, 60 years ago when the first fleet came through, and there's ways to deal with it, but it wasn't quite the PRA risk-informed environment. So how can we deal with that in a structured way to still make good decisions given the uncertainties that we can identify in data? And then, when you first start up a facility, if there's, kind of break-in failures in what we call the bathtub curve, where there's an initial period where maybe you have more failures and then it's steady for a long period of time until things wear out. Our current approaches assume we're in that middle range where everything is pretty steady. Well, if we build something new, we're going to be back at the beginning of the curve possibly. So we just need to be prepared for that and be able to address that. And then how do we prepare for and manage long-term data collection in this new environment? So the microreactor, the current approach going through INPO works well. How do we need to plan for that in the future for data analysis so that we can shift that burden from engineering judgment and lack of data to stronger data-based approaches for data analysis? So we'll be diving deeper into that this year, and think that that's another place where realism can be improved for the advanced reactors. Lastly, I wanted to mention a few other ideas that are more in the thinking stage. The question was this morning about graded approaches. We think that's possibly a good research question, especially for advanced reactors, because if you are at a lower risk facility, how can we still use the power of PRA and the structured approach of it, but maybe in a simplified manner if we're at a smaller or lower risk facility? How can we use those same approaches or alternatives to PRA for those lower risk hazards or facilities and still gain the same valuable insights that we're getting today? For decision-making purposes, there is good guidance out there already on treatment of uncertainties, or at least identification and evaluation of uncertainties. But then how do we really want to approach that from the advanced reactor perspective? Does everything have to be medians, 50 percentiles, 95th percentiles are useful? We also have to look for cliff edge effects. Again, was also mentioned earlier today. How can we structure our approach to PRA, the results, and the decisions, and make sure that all fits together very nicely for the advanced reactor so that the insights are still useful as we go forward? And lastly, we're always trying to evaluate new topics. So if you're an industry or regulator or public or whatever, and there are issues that you think a gap needs to have research, we're always looking for partners to work with and ideas. I think that brings me to the end of mine. So thank you very much for your attention, and when the time is appropriate, be happy to answer any questions.
I think the time is appropriate now. Thanks to both Marty and Eric for their presentations. Let's go ahead and open the floor. It looks like I've got a couple hands. Give me a second. Ed Lyman, you should be able to unmute and ask your question or provide your comment.
Great, thanks. It's Ed Lyman from UCS. So referring to Marty's presentation, I had, I guess, a comment and a question. So the comment is with regard to the exchangeability of data. and let's say using legacy French data for sodium-cooled fast reactors, I'd just like to raise the issue that, the French PWRs have been experiencing cracking. The design, of course, is very similar to U.S. Westinghouse PWRs, but there may be subtle differences that are explaining why the French are experiencing and the U.S. aren't experiencing it. If let's say the U.S. was just looking at French data for PWRs to inform their own, let's say, design of a new PWR, they might be using that data, would not necessarily be particularly helpful because, to my knowledge, they don't even fully understand the mechanisms yet and why it may be. I think they have hunches, but I don't think they really know. And they wouldn't have known there was a difference if not for the fact that the U.S. and the French were both operating these reactors for decades. So aren't there limitations to the use of, this legacy data for novel designs when it's turned out to be an issue even for very well-known designs? That's my first question.
Yes, hi, Ed, it's Marty. I absolutely agree with you. You can't just blindly use somebody else's data and then make an argument that it's exchangeable. So a certain amount of caution is involved in how one goes about this. But I think it comes down to a matter of judgment. I would use, legacy data as almost a starting point to inform my expert elicitation. Again, as I said, the idea is to try to capture the center and the body and the range of the uncertainty. And so legacy data, from French plan or Japanese or wherever it comes from is a starting point, but it's not the end all answer.
Sure. And my second question, since you pointed out that you had worked on the Clinch River license, so my recollection was the NRC's position at that time with regard to physical containment was related to whether the probability of severe accidents like the HCDA could be excluded, or the probability could be determined to be low enough. And this is relevant again, as you're probably aware today. So my question is, I'm concerned about circular reasoning and the use of of unrealistic PRAs to rule out through probability thresholds consideration of accidents that might lead to significant design changes at the construction permit stage. And isn't there an issue with making significant design decisions based on PRA results when the PRA itself is not validated or realistic? And so you might end up in this circular loop of, confirmation bias. So just wanted your thoughts about that. Thank you.
Yes, I tend to agree. It was one of the things I struggled with when we were in the process of endorsing industry's licensing modernization project, because there you literally start with a blank sheet of paper and you're using the PRA, in fact, to derive the principal design criteria. But even that description doesn't really describe the way it's done. You have to have a design. And what LMP says buried deep inside it is, well, why don't you start with, for example, the advanced reactor design criteria, which are based basically on the principal design criteria from Part 50 Appendix A. So it's not actually a process of starting with a blank sheet of paper. It is a winnowing process to get down to the right set of principal design criteria. But yeah, I appreciate the concern with the PRA if done poorly or without an appreciation of the lack of realism or the conservatisms could tell you you don't have any problem at all. And that's not realistic. It's not helpful.
Sunil, I saw that you had your hand up, so I promoted you to a presenter, so you can go ahead and unmute at any time you'd like. You don't need to raise your hand. Did you have something that you wanted to
I have a
provide?
question
Okay.
for Eric. Yes, I have a question for Eric. Eric, with respect to the risk matrix for that you have developed for the advanced reactors, based on what you presented, it sounded like an advanced reactor would require a level 3 PRA to compute that number. Did you, in the process, consider maybe alternatives like a release frequency as a risk metric?
The first part of your question is about the level 3, and it's the one that we suggested is kind of lands right at that border of level 2, level 3. It's, you know, in a sense like LERF, but you take it a half a step farther and identify the dose from that release. But it's not going all the way to the, you know, you're not propagating it off site beyond the boundary and looking at the widespread effect. So it's kind of part of the motivation was that concern of you can do a level 3 full PRA, and that can help you show that you meet the QHOs. But on a sort of a day-to-day basis, what would you want to use? And so that finding some sort of a surrogate at that dose exceedance level, we thought was a good compromise to have that surrogate. And then the second half of your question was,
yeah,
go ahead.
No, I was going to say, so wouldn't it still require an applicant to develop a spectrum of sequences as opposed to 1 or 2 domain sequences and the associated consequences for those different that spectrum and
Possibly.
then sum up the numbers?
Yeah, I mean, you know, just like a PRA does today with a LERF calculation, you could categorize them, you know, simply where you can, and then in a more refined approach where you needed to, and just you would have that different end state instead of, for example, LERF or something else from a level 2 PRA.
So whereas if you had chosen a release frequency, then you don't need that, and then you pick a release frequency and make sure you pick it in a conservative way so that the expected doses are not exceeded. I was just, I because we have heard a lot of, you know, concerns with some of the applicants about the, you know, too much burden associated with developing PRA. So that's the context of my question, Eric, if you don't mind. Okay.
Yeah, no, I think it could work in a very complex model or a simplified model. It would just depend on the design and the need.
Okay. All right. Thank you.
All right, I've got a couple other hands, and then I've got a couple questions from the chat. Jodine Jansen Vihek, you should be able to unmute and ask your question or provide your comment. Jodine, are you with us? All right, give me a second. He's having a little bit of problem. Got one more trick that I can try. All right, can you give it another try? All right, sorry, Joe.
Can you hear me now?
Oh, there we go.
Hi, this is Jodine Jansen Vihek with BWXT Advanced Technologies. And Marty, this one's for you. I know we have the SVPs for the current fleet, but looking forward to all of the new reactor designs and everything, it seems like that would be an extreme burden for the NRC to have to develop SVPs or the SPAR models for all of the new designs. Is the NRC considering just using or working with the utilities to use their PRA models for the future and new reactors so that we don't have like the duplicate efforts, or what's the consideration going forward for the advanced reactors?
Yeah, hey, Jodine. I don't think any firm decisions have been made yet over whether we're going to build out spar models for all the advanced reactors, or we could somehow adapt licensees spar models like that, or even if there would need to be a spar model, things like that.
And the
So,
follow-on question from that is, for some of our advanced designs, like the transportable ones, the maritime ones, and like that, where we don't have a fixed location where they're going to physically be and they could change, have you guys thought about what the metrics should be for off-site release? Or do we look at a specific boundary or release frequency, or has that even been a consideration yet?
that's a very good question. I hadn't thought of that one yet. Yeah, sorry, I'll have to defer on that one.
Eric, do you have any thoughts on that one?
Well, I think if we can find those, when you're doing the full level 3, you're going to need this, are there mountains nearby? What's the weather? Those sort of considerations. If you're using something that's a surrogate, whether it's the one I talked about or something different, those might be more appropriate because you could define a very small boundary likely around your microreactor facility and do it in a way that's somewhat bounding or envelopes different weather patterns, and hopefully that might be more appropriate. Just thinking off the top of my head, some sort of surrogate that doesn't depend on all the details of the location.
That gets down to all of the external events as well, because your seismic's different depending upon where you are. You have no idea what it's going to be. You don't know the wind patterns. You don't know any of that. So that's one of the questions we're trying to figure out is, should we just use a frequency and try and keep below that? Should we just use a boundary and assume a certain thing? Or what would the recommendation be from both the industry and the NRC side when we're looking at some of these novel reactors? Or if we can show that the release frequency is so low, do we even need to consider that? That's where we're coming from.
Yeah, I understand.
So,
All right, I've got a number of, sorry, go ahead.
Sorry. No, I think Barry is ahead of me, so let me just wait until Barry has his question, and then I have as opposed to a question, I had an observation. Oh, by the way, I forgot to introduce myself. I'm Sunil Virakuri. I'm the PRA level advisor in NRC for the operating reactors. Go ahead,
Thanks,
Barry.
Andy.
I'll save my question after you ask yours.
Yeah, I've got 2 hands. I've got 2 questions in the chat, and then we'll go ahead and move to break. So Barry, see if you can unmute and ask your question or provide your comment. All right, give it another shot. Barry, are you with us? All right, not getting anything from Barry, unfortunately. Sarah? See, you have your hand up as well. There you are.
Yes, can you hear me?
Yes, we can. Please ask your question or provide your comment.
Great, thank you. My name's Sarah Abramson. I'm the executive director of C10. We're a group around the Seabrook Station reactor. And I just wanted to ask, this is a program that we actually offer the consideration of real-time monitoring in the host community, in addition to the real-time monitoring that's done on site by licensees, and I would expect or hope would be required for advanced reactors as well. There's nothing more real than the real-time monitoring that you can get of the air, and I'm aware of the DOE sponsoring some development of promising technologies to provide real-time water monitoring as well. So I just wanted to think about how that can be incorporated into PRA Realism, how you could leverage that information. I also wanted to ask about, and it might dovetail into what was mentioned earlier with the SPAR modeling, the corrective action program that licensees keep seems to me like a treasure trove of data that is maybe untapped and could be leveraged for this. I'm aware that it's not something that's public, but I didn't know if that was something that you've considered or implemented kind of to supplement the disclosures that come through IMPO. And then I also wanted to make a comment about the climate change impacts. I read the NRC's response to the GAO report about assessing, climate change impacts, and that usually falls under the ongoing assessment of natural hazards information. And I guess I was curious how this PRA Realism team and this review is interfacing with the groups that look at those natural hazards.
Yeah, boy, I haven't really thought about climate change. Brian, you want to?
Hi, this is Brian Smith, NRC. So climate change and Poani. We do, as other parts of the government, produce reports relevant to climate change and the changing conditions. We do take those under consideration, evaluate those, and determine if any changes are necessary for any of the impacted licensees. If there are impacts, then those would be applied to those licensees, and the impacts on the PRA would be considered after that. So it's not kind of I don't know, PRA wouldn't come first. It would be kind of after the fact in that area. So it's all part of the Poani process that you mentioned. Let's see, what was some of the other questions? Yeah, you had several questions. I think that was the last one. What was the first one again, briefly?
Real-time monitoring in the community, sort of outside the boundaries of the plant site. We're a group that actually performs real-time monitoring, but we're aware of, other states sort of embracing real-time versus static TLD type monitoring. And so there is real-time monitoring data out there between EPA, RadNet, and groups like C10 and SafeCast. And I'm just wondering how you're thinking about leveraging that when you're considering, this PRA realism review.
I don't know that really factors into the PRA realism aspect of it. Under normal operations, the off-site doses should be within regulatory limits. PRA, I assume, is more focused on the larger accidents and releases off-site. If there were an accident like that, having information available to us off-site would be beneficial. So what was your second question?
The corrective action program data from licensees, which I know contains everything from like a broken, water fountain all the way up to something more significant. But instead of relying on what it sounded like was a pretty voluntary disclosure program through IMPO, how might that treasure trove of data, as I think about it, be leveraged for this purpose?
Take it, Nick.
So I have a response for this, at least from my own personal experience. This is Nick Melly from the NRC and the Office of Research Fire Protection Branch and External Hazards. The CAP system has been dove into pretty extensively when we were looking at the fire events. EPRI did a very extensive dive to collect the fire event data that would lead to the fire event frequency that we now use. I think diving into that specific system captured something like 700,000 reports. And like you said, it could be anywhere from a smoke detector in the cafeteria to the sprinkler system out in an office building. And we had to filter through all of that data to then inform what was actually relevant to the PRA. We have since created guidelines for the plants to actually look at when they're looking at their CAP system and then report to INPO. So we're hoping that these processes that we've discussed to collect the data in the new plants and to filter things to INPO is going to be already put in place, so we won't have to do that filtering at the large level of the cap system, so that INPO is going to get the streamlined information that we actually believe is relevant to the PRA. So it's a good question. There is a lot of good data out there, and things will ultimately, hopefully, not fall through the cracks. But the hope is that the info that INPO gets is going to be the relevant information that we are going to use to develop the data further.
Thank you. I have one last question, and that is how you are considering the presence of another existing legacy reactor where you might cite new advanced reactors, how the presence of those different types of reactors on the same plant site interact with each other's PRAs.
Yeah, in general, the non-LWR PRA standard worries about multi-unit, multi-module risk, and so one would actually have to model those. Normally, when we think about multi-unit risk, all the units are relatively close to each other. When you begin to space them out by a couple of miles, it's a little bit different calculation.
Hey, Marty, this is Sunil Virakuri. I can provide a perspective on that. The fact that you have multiple reactors on the same site is not a new thing. I remember when we did the IPEs for Millstone 3, okay, you got 3 reactors on the same site. And so one of the things that could happen is you could have a common initiator that concurrently affects all 3 sites, and that's captured into your PRS pretty well. And then when you think about the independent events, the likelihood of one plant's event happening, and then the risks are, I wouldn't say insignificant, but they're not that high. I mean, you got to think about the potential effect of a release from one plant, how it could affect the control room habitability of another plant. But it's been thought through in our past PRAs because we have a lot of plants out there on the same site. So the fact that if you have an advanced reactor that's going to be situated on the same site, and how you deal with in the PRA realism, I don't think that's going to be a insurmountable challenge.
All right, I want to give Barry Quigley one more chance to see if he can connect. I've got you promoted to a presenter, so you just need to unmute.
Okay, can you hear me now?
Yes, we can.
All right, so the questions relate to basically operator performance. One thing that I have personally seen is a crew being confused by multiple indications failing. And we wrote it up as a training scenario. Basically, it was written up as a fire. And I went through and found all the instruments that would fail during that fire. Then I ran a simulation, and the things happened over a period of time, and the crew could not handle it. So what I'm getting at is when we have all these very, very, very severe events, it's going to be, where are they getting the data from to make decisions? Is it a good spot? Okay, so that's just a statement. Okay. Another thing that was brought up in the meeting in October was about using the simulator to assess human performance and human errors. I don't think that the simulator is going to give you valid data, because you're extrapolating quite a bit. You're taking a simulator, Monday to Friday, the lights are on, air conditioning's running, and you're assessing events or a human error. But in the real event, It's gonna be a lot different than that. It'll be cold, hot, dark, whatever. And plus, people are gonna be worried. You know, if it's a tornado strike, is their family alive? So trying to extrapolate simulator data to PRA data, there be dragons. I'll just say that. Not really looking for a response. If somebody wants to respond, that's fine. But I just wanted to get those comments out there for consideration. That's it.
All right, appreciate that. I'm going to go ahead and bring an end to this particular session. We need to move quickly if possible. Just to start our public perspective session. I know I want to take a break, but I know Ed Lyman, who we wanted to have a chance to speak, has a conflict starting at 2:30. So Ed, you should be able to unmute, show your screen if you'd like to, or put your camera on if you'd like to. So we're going ahead start our public perspective session. I still have a few questions in the chat that we're going to loop back around to later, I promise. But once Ed has a chance to speak, then we're going to take a break and come back and see if any other members of the public would like a chance. So Ed, I'll turn the floor over to you.
Thank you, and I appreciate your accommodating my schedule. And I'm going to leave the camera off because my Teams connection usually has problems. I'm just going to make a couple of quick comments. I don't have any slides, but you know, UCS strongly endorses efforts to bring more realism to PRA. So all of that is well and good. But my concern after listening to many of the presenters at this workshop, especially the industry participants, is that there seems to be a presumption that increased realism means reducing conservatism. And that leads, I think, to a significant bias, which could affect the ultimate outcome of any such efforts. So I think Marty Stutzky put it well. And if you don't know, you know, if your starting point has a lot of uncertainty, then adding more realism, you don't know if it's conservative or not. And the problem with risk-informed regulation since its inception has been a significant bias toward the notion that increasing the use of risk information is only going to reduce conservatism, when I think a priori you don't know that. So you know, I'd like to see less emphasis on the notion that making PRAs more realistic is only going to reduce conservatism, and that especially applies to the highest uncertainty parts of the analysis, including HRA. And so to that end, just citing one example is the incorporation of flex strategies into PRA. I think there's good reason to be skeptical that any such quantitative values for that are always going to be very uncertain, especially since I don't even know of a single actual scenario that's been run that could validate these a full-fledged flex type scenario implementation. There are just too many uncertainties and too many variables. So when I hear that there are plans to incorporate flex into the baseline SPAR models, I would caution that it's very useful information for the public to know the impact of assuming successful flex strategies and how that affects the bottom line core damage frequencies. And so I would hope that that would always be available and considered separately, so the public can see how the impact of those flex strategies is what that impact is on CGF, because sometimes it's an order of magnitude or more. You know, I think there has to be a healthy respect for the uncertainties that you're really never going to be able to fully resolve. And so to that end, you know, with respect to the PRA policy statement, you shouldn't go beyond the state of the art. an application. And I fear that the NRC has gone beyond that, both for operating reactors and new reactor applications. And increasing realism could help with that. But still, I think you have to appreciate what you don't know and don't give misleading impressions, both internally and externally, that you know more than you do about the risk. And I'm concerned about that impact on both operating plant oversight, including SDP determinations, as well as the new plant licensing and the circular reasoning that I referred to otherwise. And my last comment is going to be on the addendum number 9 to the DOE NRC memorandum of understanding on advanced reactor licensing. And someone has to say it, but that addendum, which the NRC has accepted and will presumably be incorporated into the rulemaking package that's coming out next month, has some language about risk and what the issues that the NRC is going to be allowed to evaluate independently when reviewing DOE authorized reactor designs. And my main concern here is that I have no idea if the DOE authorization, to the extent they're actually using quantitative risk and validated PRAs in their authorization process at this point, especially for the pilot reactor program. And so I have serious questions about how NRC's own framework for evaluating risk is going to be applied when the agency is called upon to rapidly license DOE authorized reactors, as the MOU and the executive orders seem to suggest is going to have to happen. So I'm very curious and concerned about the interface between the DOE authorization, NRC licensing, and how the NRC's decades-long and very thoughtful mechanism for assessing risk is going to be applied in this case. So those are my remarks. Thank you.
Thanks, Ed. Okay, plan is we're going to take about a 15-minute break, let people get up, move around a little bit, stretch their legs. I'd like to come back and can keep the floor open for members of the public. If there's anyone else who would like to have a little time at the microphone just to provide some perspectives. I want to loop back around. I still have a number of questions that were provided in the chat that I want to make sure that we at least take a shot at. And then we'll go ahead and move into our open discussion portion before we close today. So take about a 15-minute break. Let's shoot for maybe around 2:45, maybe a couple ticks before. people can please find your seats, we're going to get started back in the next minute or so. If people can please find your seats. All right, so as we discussed prior to taking the break, since we went ahead and opened up the public participation session, we wanted to go ahead and continue that. So if there are any members of the public that would like a few minutes at the mic, well, if you're here in the room, please raise your hand. If you are participating on Teams, please go ahead and raise your hand and we will give you the ability to unmute. Again, just looking for public participation, couple minutes. If you have a particular statement that you'd like to make, go ahead and pause and see if we get any takers. Hey, Sarah, you should be able to unmute and provide your comment at this time.
Thank you. This will be very brief because I think I got a lot out during the question and answer. But I wanted to just note that as a community advocate, we view the #1 defense in depth tool as being the human resource, the NRC resident inspectors. You know, I read the inspection reports very closely. And, you know, there are oftentimes things missed by the plant operators that the inspectors find. And that's typically just a sampling, you know, 10% or less. And so you can sort of apply basic linear math and theorize how many things are going unnoticed. So I've been hearing that perhaps resident inspectors might not be required at some of these advanced reactor sites. I don't know how this factors into your PRA analysis, but understanding that a lot of the previous data collected from other sites, there might have been some risks that were averted because of the presence and diligence of the inspectors and the ROP program, which is, you know, currently being changed quite a bit. So I just wanted to put that on the record of the importance of inspectors and that they're given a lot of latitude to do their job effectively.
Thanks, Sarah. Any other members of the public at this time would like a chance at the microphone? All right, well, this is certainly not a speak now or forever hold your peace kind of thing. We will have some open discussion coming up as well. So what I'm going to do is I'm going to loop back to those questions that we had in the chat that we didn't have a chance to address. These popped up primarily during Marty and Eric's presentation involving the advanced reactors. So I would probably ask that they take the first shot at addressing them, but they might not specifically be for the two of them. So I'm going to start with how should we look at risk for a unit versus risk for a site? A single initiating event could cause small dose for one unit, but may add up. Obviously, there are benefits to multi-unit too, particularly in defense in depth. How can we deduct credit? I don't know if Marty or Eric or anyone else wants to take a shot at this or has some thoughts on this one. Go for it, Marty. And Eric, you are still a presenter, so feel free to unmute if you'd like.
Yeah, I'd say the techniques for looking at these multi-unit, multi-source scenarios are being evolved. That being said, the Office of Research has recently completed a multi-unit level 3 PRA project that took many years. And it showed that the risk contribution from both units was about 10% of the total. So it's a very interesting study result. But, you know, you look at all these scenarios like a seismic, you know, an earthquake gets both units in trouble, or one scenario ripples into the other unit, that type of thing. So the techniques do exist, albeit they're a little tedious to apply right now.
Mhm. Yeah, this is Eric. I'll agree with Marty. There are some things that have been done for the current fleet in their traditional setups. And there's some work as well that extends it and looks into whether you add advanced reactor to an existing site, or you have all new reactors with more combinations. And so some of that guidance exists, and the PRA technique should work well. You just have to ask a few different questions, and then, from a regulatory perspective, the NRC can address that.
Thanks. And I've got, sorry, go ahead. Okay, I've got an add-on comment to that. Follow up on the multi-unit, similar above. Clearly, the risk to the U.S. public would be lower if all new plants were co-located, so we should be able to credit that benefit realistically. Okay. Couple other questions. The PRA seems to be focused on the evacuation of the public. Is there any effort to applying the methods and models to the ingestion and long-term risks to the public that can occur with unplanned emergency releases below the evacuation guidance? Sure, Sunil. Sure, and here.
The question says that the PRA seems to be focused on the evacuation of the public. I'm not sure I agree with that. And if the person who wrote the question can clarify what he meant by that.
Sunil, can you introduce yourself again?
Yeah, I'm Sunil Virakodi. I'm the PRA senior level advisor for PRA in Office of Nuclear Reactor Regulation.
Mr. Adams, are you still with us? If you can, there you are. You got your hand raised already. Give me a second. All right, by all means, please unmute and.
Yes, I will see if I can explain. The reason I made the statement about the focus on the evacuation risk is in the slides themselves, and in prior discussions I've heard about probabilistic risk assessment. The threshold and the comparison is always made to the 500 millisieverts or the 1 to 5 rem dose evacuation threshold for decision makers, and that is always the context in which PRA is used when discussing public risk. And I was inquiring if the model has been used, and I just haven't heard about it, or efforts been made to use it when regarding the longer term risks that might be occur to the public on a release that is lower than the evacuation threshold, say one that only reaches 700 millirem or a 7 millisievert dose to the public, but that's for the exposure during the released period of those 4 days, but also now applying it to that longer term ingestion risk using the FDA or EPA derived intervention levels, and that calculation of risk to the public, because all of the slides today talked about the public consequence risk consideration in terms of evacuation risk.
Okay, so I think I have it. Thank you for that clarification. So I'm going to try and answer that question, and I'm going to ask Marty here to correct me if I'm wrong. When we do the level 3 PRA risk assessment, we do consider the risk associated with releases, including that's coming from ingestion and all that. I think the context of using those thresholds that I think Eric proposed, that was more in terms of a metric as opposed to how you actually calculate the risk using a level 3 PRA. Marty, did I miss anything there? Or?
No, I agree with you, Sunil. The way that the level 3 portion, the consequence evaluation works is the release is postulated, and the radioactive material is dispersed into the environment according to the weather conditions and things like that. If doses in a particular area surrounding the site exceed the EPA's protective action guidelines, then the computer model assumes an evacuation at a given speed, so forth and so on. If the repopulation guidance occurs, then the computer model will assume the evacuated people move back to their original homes surrounding the plant. And so then it accumulates the deaths over a 50-year time period. And what our studies have shown from the state-of-the-art reactor consequence study, SORCA, as well as the level 3, is that the bulk of the dose comes from the population moving back into the evacuated area.
So the again, this is Sunil Virapudi. So the risk you encounter from ingestion gets factored into the level 3 PRA risk assessment.
Well, he mentions the EPA public protective action guidance, and that only encounters the inhalation risk and the external exposure. It does not incorporate into those models even for the intake of foodstuffs in that area and the water supplies. That's under not the protective action guidance, except there is a small allowance in the 2017 EPA protective action guidance that does cover water uses during the emergencies and changing away from the typical day-to-day gross alpha beta thresholds to emergency temporary measures, but it's not part of that calculation to model or incorporate the ingestion intake of radionuclides in the environment, which is why if you're solely looking only at the EPA emergency protective action guidelines and not incorporating the FDA DILs, that's where I mean when I say ingestion. I don't just mean the inhalation risk, but the actual intake of radionuclides from the environment outside of that evacuation area or within that evacuation area when you remodel the return. It's not actually, that's why I was asking if you were doing PRA with those risks also incorporated.
And this is Eric. I'm sorry, I lost connection there for a moment, but I think I got back during the discussion. And I think everything you said is recognized. The one that I was talking about was one option for a surrogate. You would still have to show that when you went to the full level 3 and you assessed everything that would be in there, as you mentioned and Sunil and Marty mentioned, that those would still also be valid. So if there was another specific question that I missed while I was reconnecting, please let me know.
No, there was not a specific question. It was clarification to make sure that I both understood your answer and that you fully understood my question. That was it.
Okay, good. I hope I helped.
Charles, did that take care of all the questions that you had?
Unless I misinterpreted their statements about that the modeling is solely based upon the EPA's protective guidelines from the EPA 400 2017, and it does not incorporate any of the derived intervention levels for food intakes or modeling. That is what I understood their answer to be.
For that specific use of a surrogate metric from my perspective, from the EPRI research perspective, yes. And you could certainly modify it to use whatever numbers or criteria you wanted. It's not a definitive only one way approach.
Okay.
All right, with that, Marty, I think you can run for it if you'd like. Let's go ahead and shift to kind of talking about general feedback and discussion. And then we'll move on to priorities for future activities. So, Brian, do you want to kind of take the stage? I don't know if you want to sit or if you want the microphone. Okay.
All right. Once again, Brian Smith with the NRC Office of Research. So for this part of the open discussion session, I just wanted to see if there were any other areas related to PRA that we may not have touched on in the first day or the half day of today that anyone thinks we need to talk about at all. I mean, we covered a lot from both the modeling perspective and the data and analysis perspective, then somewhat how it's used. But if there are things that we missed that someone thinks we need to discuss, please speak up, raise your hand.
Charles, go ahead. You should be able to unmute.
Okay. I had one other question that had been in the statement in the chat earlier, which was based upon my knowledge of PRAs entirely consists of presentations, both this one and other prior presentations that the NRC has given. But I wanted to ask, because it came up as a topic today, does PRA make allowances in the model for bad data, such that the margins would be sufficient to still be within acceptable limits if something happened to the data that was used for the model, such as what came out today in the news about earthquake data at some of the Japanese nuclear sites, where the watchdog there, the NRA, has pulled a safety review after the seismic data was found to be false that was given to them.
So can you repeat the first part of your actual question again?
Yeah, okay.
So
Does PRA model or make allowances within the modeling for bad data on the input, like data that is incorrect or inaccurate to a certain degree? Or is it presumed that all data is 100% accurate and the model only acts upon or allows for data that is actually truthful and accurate?
Chris Hunter, Office of Research. So just for understanding, we factor in the parameter uncertainty in our calculation. So we don't use a single value. We use a distribution on, so I don't know if we really ever kind of account for that being bad data, but just being uncertainty with the data that we're using. And so we evaluate that. I think if something was, for example, some kind of flooding frequency was so out of line that it really didn't even fall within, the bounds of what we're kind of looking at, obviously that would just be something we would need to fix down the line with our evaluation. But I think in the most part, that's just, we update our values and well, certain calculations within our PRA and whatnot, we do update, and we would factor that in the next kind of update. If they're kind of single calculations or single projects, we're probably not going to go back in and recalculate using a different value. So I hope that answers your question.
I think it does. I said I wasn't sure if in the human risk factors analysis portion there was an allowance made for false or the human tendency to bias data. It sounds like you do set margins around the data numbers you use, but those numbers are based upon the state of science and knowledge about that. It doesn't actually have another factor somewhere for make that bias or that human tendency for falsification.
No,
and if that's a
again,
correct
some-
understanding on my part, I thank you for your
yeah.
time.
Yeah, I know. I think I wanted to kind of emphasize one point here. I think PRA technology, obviously, I have a biased view because that's my area of expertise. I usually brag that this is one area where we expend significant efforts to address the treatment of uncertainties. In fact, we have a document called NUREG 1855, which documents how thorough we look at the uncertainties of data, different kinds of uncertainties. Chris mentioned parametric uncertainty, and we also consider other uncertainties like the modeling uncertainties. And you referred to some news article about seismic issue that came out today. I haven't read that article, but I have to say that if we learn some major issue or something out there that challenges our prior knowledge with respect to, hey, we thought something was that way, all of a sudden there's an international or national experience that challenges that. We have a process here within the agency to promptly look at, hey, how significant is this? It's called the LIC 504 process, and if we believe that based on that process that we need to take some prompt actions, we have a process for that. So I just wanted to clarify that. So the data uncertainty is not, it's something very well thought out in the PRA area.
Yeah, so two related things to that we've talked about today. One is the Puani process that came up about changes in climate data. That's something that we would evaluate and potentially make changes if we needed to as well, and the licensees. What was the other thing? Yeah, I did see briefly the report you're talking about a plan in Japan that's proposing to restart, and they utilized the wrong seismic analysis methodology that they characterized to the regulator.
Yes, and that was, I'm glad to hear that we use an evidence-based self-reflecting process as was described earlier. And yes, my question wasn't around the science. I'm very reassured to hear that we do update and we monitor that. It was more along the lines of what you mentioned specifically from that article about a human mistake or not mistake. Who knows until the lawsuits all fall out, I'm sure, as to where that data inaccuracy came from, but the purpose or the reason behind it, but it's just whether or not there was any margin built because of that. And it sounds like not so much around deliberate or accidental human mistakes on the data.
Yeah, this is Nick Melly with the Office of Research Fire and External Hazard Branch, and that is something that we pretty explicitly deal with. The fraudulent nature of data is a little bit tougher to explicitly deal with in the distribution. However, the human bias factor is something that is explicitly handled. One example of that is in the SHAC expert elicitation guidance. There is data bias and calibration training for the expert elicitation members to partake in at the beginning of the expert elicitation process so that they can understand the human factor, the bias that you're bringing into a particular question to shape that distribution. If you want further detail on how that's handled, it's in New Reg 2213.
The other thing that I wanted to mention that we talked about it briefly today is the LIC 504 process, which Sunil just mentioned, and link that back to what Ed mentioned about the cracking of some of the pipes in France and the PWRs. That is something that we did evaluate. The LIC 504 it's an NRR office procedure where if there's a significant issue that arises that we want to take a look at, an in-depth look at, and we do it on an expedited manner, we do that. And for those cracking issues in France, once we had sufficient information from them, we did that evaluation to see how applicable those issues were to the plants here in the U.S. So I'm not sure if the results of that are publicly available, but I know we have given presentations in the public about that. So
Sarah, go ahead. You should be able to unmute.
Thank you. I just wanted to add to this conversation and maybe ask the question, pose the question. When you're looking at a lot of the historical data to evaluate how you would approach, PRA realism, are you looking not only at the frequency of incidents, but also how long it took for an incident or an issue to be identified? What comes to mind is tritium plume leaks. There are quite a few examples that were going on for many years before discovered. And then personally, living near the Seabrook Station reactor, the presence of the alkali silica reaction driven concrete degradation was mislabeled for many years as just typical structural aging or thermal expansion. And so how are you quantifying and then applying that something might get misdiagnosed or not diagnosed at all?
Yeah, thanks. Hi, this is John Lane, Office of Research. I'm the data project manager for the national lab activities. Generally speaking, we go back approximately 15 years when we're accumulating data for our parameter updates. We typically go back 15 years or longer, depending on how consistent the data is. But in the process of that, we do look for anomalies. But basically, we're not just taking a snapshot of data. We're looking at a whole range of time. And the hope there is that you're basically covering any eventuality of an error or a change in methodology or attitude or something like that. We're trying to pick it up in that manner.
This is Nick Melly again with the Office of Research, and that time dependence is built into several areas. Specifically, the STP does have time of degradation factored into the calculation that is handled in the STP process, as well as when we're looking at the reliability and availability data of certain aspects that are factored into the PRA. The time of degradation of some of the unavailabilities or the failures is factored into how we're using that data in the PRA.
Chris Hunter, Office of Research. I just wanted to kind of just quickly add on to, in terms of event and condition assessment, the exposure time, which is what we use for degraded conditions event assessments. We use a maximum of 1 year. So the individual risk assessments only factor in the most recent year. So it is that understanding that these individual event assessments do not calculate the entire risk over if you had a long-standing issue of, say, 15, 20 years. We do acknowledge that limitation. We do have the accident sequence precursor index that we've kind of acknowledged that issue and try to address that at least partially, where we actually include the risk associated with that long-standing degraded condition in all the years that it was actually applicable. So we do understand that as a limitation in our analyses, and I think the ASP index is really the only thing we do at the agency to actually account for that. Thanks.
So following the first day of the workshop, one of the folks that attended sent us an email with some comments. It's a couple of pages of comments of discussion. It kind of boiled down to three things, and I'll just kind of run through the three things fairly quickly. The first, it's Ralph Caruso, was the member of the public that submitted these via email. How does the NRC intend to identify, quantify, and model accident sequences that do not appear in the PRA. How does the NRC intend to identify, quantify, and model cultural characteristics of whatever source and type that contribute to reactor risk? The second one was, finally, I wonder what the NRC is going to do about the role of artificial intelligence in the design, construction, operation, and maintenance of nuclear plants. For that one, we at the NRC have developed a plan for learning more and about, I guess learning more. We have a strategic plan related to AI that we've been implementing for the last year or two. That's looking at how licensees may use it, how applicants may use it, how the NRC may use it as well, and the things that we're doing in that area. So that's something that we're learning about now, and how well AI or the current state of AI may actually function in doing those and providing reliable results that licensees and the NRC can rely upon. So it's an ongoing process. The third one, if the NRC really wants to update its concept of risk, I would suggest that it look at the LNT, linear non-threshold theory, which has been used to develop all radiation exposure limits and guidelines for occupational and accident doses. This is one that we've been actively evaluating for the last year as part of, actually less than a year, as one of the responses to one of the executive orders that was issued, 14-300. There's actually a rulemaking that is ongoing now that will address the LNT issue. So the public will know more about that when the proposed rule is issued for public comment. So if we can go back to the first question and see if there's anybody here that might address this. How does the NRC intend to identify, quantify, and model accident sequences that do not appear in the PRA? How does the NRC intend to identify, quantify, and model cultural characteristics of whatever source and type that contribute to reactor risk? So anyone take a shot at that? Chris?
On the second one. So I can try to answer the second one with respect to the cultural. We don't necessarily have to go in and have a explicit modeling of the culture in the PRA itself. Every organization has a culture. When you say culture, you talk about all the practices within the organization, and they have a way of manifesting into the kind of failures that do occur at a plant. For example, if you have a company that doesn't have a good safety culture, as time goes on, that reflects into increased failure performance, more failures, and that would reflect into the PRA or the event assessments, and it will come to our attention. But I don't think we necessarily do or have to model culture as an explicit element in the PRA itself. It is implicitly captured. That's my view on that. There may be different views on that, but that's my thought on that. Again, this is Sunil Virakodi. I forgot to mention my name.
Chris Hunter, Office of Research. I'll take a stab at the answering the first question. I think the simple answer is we don't really know right now. In terms of event assessment, I've been asked by my supervisors and bosses of how are we going to evaluate potential ASP events for plants that don't have PRAs, and I think a lot of, or at least a few of the discussions as part of this workshop talked about the fact of needing to look at different metrics. So I think everything is on the table, but bottom line is, we're thinking about it, working on it, and more to come in the next few years. Thanks.
All right, so now I want to kind of move into kind of a combination of the two open discussion sessions and kind of go through the end of this and start looking at actions we may be able to take and priorities for activities going forward. And some of this may be just going through the agenda from the first day and the second day and seeing if there were items that came up during those sessions that we want to try to focus on going forward. I have a few notes Like I said, I hope everybody else took notes from the first day. And so we can refresh our memory on some of these things. We talked about data in the first day. Data is something that we kind of do jointly for the most part. We rely upon the information from the licensees that's submitted through IMPO, through our event notifications as well. The data that we evaluate from those sources is utilized by us in our SPAR models, also by licensees in their models, and we update that at certain frequencies. There may be aspects of this that we might want to talk about a little further. Common cause failure data maybe is one thing that we may want to talk about. I know, like Chris talked about, we're doing some work in that area right now. There's more that we need to do going forward. Is that those common cause failure data something that we want to talk about a little bit?
Chris Hunter, Office of Research. Just to add on to Brian, I kind of mentioned earlier in my presentation of, the hope is to, in the next month or two, to come up with a plan, kind of an overall highlights of, what we're planning to do for this part of the net data update for CCF. I think also we had a CCF public meeting, I want to say late 2024, maybe early 2025. And maybe after a month or two of industry looking at the new RASP guidance, reading it, and maybe coming together and having a follow-up meeting, maybe combined data / CCF meeting to kind of talk about these issues so we can receive feedback before we kind of move forward in the data update. So if, any Victoria or anybody has, thoughts on that, whether that sounds like a good plan to move forward,
Okay, so maybe that'll be an action we'll take on for going forward. Public meeting to talk about common cause failure and data. Okay, all right, very good. Sure.
My steps. I'm Gary DeMoss from PSCG and also from the IRIR. The two owners groups, Boiler and B and PWR owners groups are working to review common cause data, among other INL data. And I think that's important, especially in the area of common cause data, because there's so few events that just a couple of conservative calls can really affect the parameters that we're using in our decision making. So we need to continue to work together. We need to provide INL with more information in some cases because they don't have the resources or the ability to contact the utilities to really understand whether a common cause event was really a PRA countable common cause event or not. So that process, working with John Lane, has started and hopefully will continue and will help us make better decisions.
Thank you. Let's see. Some of the other areas from the first day of fire protection was mentioned that most folks know that fire protection is a big risk area in the PRAs. And what may be driving that are conservatisms in the models and some of the methodologies. So maybe ask, where are those conservatisms? Where are those conservatisms? And there may be something that we can do to address those. In the first day, we talked about issuing some frequently asked questions, response to those to kind of address the issues in a more expedited manner, as opposed to updating a reg guide or a new reg. So if there's anything that comes to mind or off the top of your head, we can talk about it now. We can set up something else in the future. While you're thinking about that, some of the other notes that I have, one of this is just kind of an observation. Fire is considered high risk, but we aren't seeing the events. In essence, it's the actual event versus the risk in the PRA. Cabinet fires impact on cable trays. And I think, Victoria, you mentioned that in your slide today. I think we do have some ongoing research that will help to address that. It's underway. It's going to be some time before it's wrapped up. I think we all recognize that conservatism there. I don't know if there's.
Victoria Anderson from NEI. So I think one thing we need to be aware of when we talk about realism in that scenario and other similar scenarios is that licensees may not always, it may not always be worth it for a licensee to go and incorporate all the detailed modeling and the detailed update and everything in all fire areas. And this is where we get into the average and base model versus scenario specific. So I think it becomes important to be able to, if you're in a scenario specific scenario, then go and apply the more realistic information if it's available.
This is Nick Melley, Fire Research Branch Office of Research. I was going to echo the same thing, is that this question is more for the practitioner that's on the phone of where do you see conservatisms coming in? Because when we have been in the past 10 years developing new methodologies or trying to reduce some of the conservatisms, the bounding approaches that have been out there, we've been doing it to try and stay in the framework of the current models that are available, or starting from scratch and coming up with a new methodology. That latter approach puts more onus on the PRA practitioner to redo all the work, reanalyze everything, and it's very cost prohibitive. However, if we come up with new approaches, we will typically have a PRA practitioner on the team so we can understand what is an easy button approach, what value can we substitute in that's going to be a bounding approach, and then where can we sharpen our pencil so the analyst can do a scenario specific solution to really dig into the detail of a particular event. And the question for the PRA practitioners on the phone is, are there conservatisms out there that we're not adequately addressing right now, either in electrical cabinets, cable fires, lithium ion battery, you name it, whatever methodology is out there that we need to dig into with EPRI to come up with a better solution? Or is this just a cost initiative of actually applying the tools that are currently available? That's the piece of information that the NRC right now, as someone who's doing the work to do the research and will sharpen the pencil, where do we need to focus our attention? Where are you seeing that there might be conservatisms driving the methodology?
Fernando Ferrante of APRI. I mean, you know, the fire collaboration has been extremely beneficial. And I think one of the things that, you know, I think informs the realism discussion we're having here is having, you know, available something that tells us, well, you know, the skyline chart where it's like, okay, what are we tackling and where is it, right? Because, you know, Nick is right. And to add to what Nick is saying is, okay, where is realism that we can improve reasonably for specific things, right? Because, you know, I think there were some comments about cultural impacts or organizational culture in PRA. Very interesting academic work. But if we're going to say, let's put that into RAS handbook, or let's make arguments about you have cultural, organizational culture, you know, we're talking about different levels of expectation and need. And so it's where can we increase realism? What does it take? And how can it be done, right? So it doesn't become a 10-year research project, which if it needs to be on something else, perfect. But you know, resources are finite. And so at some point having that sense of where is it that we can improve, for what purpose, and is there a meaningful path, right? We had the component-based ignition fire frequencies. 10 years ago, we at some point had to say we got other things to fry. Then we said, now we can do it, and we can do it realistically. So I'm repeating a little bit in the sense of the logic of what we need to tackle should be considered. I think it's very important.
And just to kind of wrap that discussion up, I know Ed Lyman's not on the phone anymore, but I do want to echo when we say reduce or increase realism, reduce conservatisms. Even in the fire field, we see that it has gone both ways. When we talk about improving realism for certain methodologies, we're actually making the model more conservative because new data has become available and the model shifts to a worse number, if you were, that makes the PRA get worse. And in fire, that happens frequently. You learn something new, the model might get worse. The fire might behave differently than you originally thought. So it's not just about knocking down conservatisms and making the numbers better. It is about getting to realism, understanding the fire behavior better, and incorporating that into our current models.
Yeah, there's justifications that are made for changing those conservatisms one way or the other. It's not just willy-nilly. So I don't know if there's anybody on the phone has any things they want to say related to that, but one of the things that Nick mentioned is that from a resource standpoint, being able to implement what we've already produced, the newer methods and some of the approaches into the licensees, PRAs, being able to have time to do that. That came up in the first day, and that was another thing that I wanted to get to as well. The industry's capacity to be able to do some of these outside the norm things for just the PRA, address some of these initiatives and make these improvements on additional improvements for realism in their PRAs. And I will come back to that. But from maybe we wrap up.
Brian, I did have a hand pop up. Charles Adams, you should be able to unmute.
Yes. So this is you asked for ideas. One of the areas that I was wondering about improvements in is the assumptions about the public actions and compliance with those advisories and decisions that are assumed in the dose savings modeled with evacuation. Many of those assumptions are very old. And is there any effort to apply or to use or to update those assumptions around the number of people who will actually comply with orders, the degree to which those orders are complied with, and also finally the, how to put this nicely, the accuracy to which the numbers for risk of what evacuation causes for as far as public, you mentioned earlier, PRA is that primary column of the public risk. The numbers for the risk of evacuation and the risk of departure orders or other orders given by the government in response to those guidelines that are modeled within the system.
I don't think we have the right folks in the room to be able to answer that question. I don't think any of us here are aware of any activity in that with what you're asking. Sorry.
Thank you. You were just, I thought the question posed was around areas where improvement could be used. And I know that many of the assumptions around that are 20, 30, 40 years old. I have not seen a review of the actual risks of ordering evacuations on a large scale that is newer than Katrina, for example, which was 2005. It might be an area in which needs to be improved. Yeah, so I probably wasn't clear enough.
I thought you were asking a question, but no, I understand. So assumptions.
You mentioned that you were looking for areas where our conservatives, our assumptions that are used in these models might be in need of increased accuracy or maybe reevaluation for the current cultural or political environment, not political, but the way in which people respond to social directives.
Yeah, so essentially it's when there's an event and they're calling for folks to evacuate the area, what are the assumptions that we're utilizing for that? Should we update those based on any newer information that may be out there?
Yeah. For example, in your PRA, you talk about when the evacuation guidance threshold is reached, the direction is given for the people to leave, and then you model what dose they get when they return. some of those assumptions about the compliance with that order are very old.
Right.
And might therefore make an inaccuracy in the dose savings to the public, and therefore change that public risk safety balance.
Okay, we'll take that into consideration and maybe pass that on to the folks that work in that area. So, okay, so
we just actually had one more hand come up. M. Miller, you should be able to unmute and provide your comment or ask your question.
Yes, I'm Mary Miller. Can you hear me?
We can.
Oh, good. I'm going to come from an entirely different direction, from one of project management and budget. For fire PRA, because of the consequences of being unable to shut down a reactor or being unable to prevent the opening of a high-low pressure interface valve, it might be worth it for EPRI, possibly a backfit analysis, but I think this is more for EPRI, that given the expense and potential regulatory risk of a PRA for fire, it might be worth it to consider simply recommending protecting the circuitry for high-low pressure interface valves and reactor shutdown, or reactor trip, rather than going through all the mechanics of a PRA, because I think the expense starts to be pretty close. And once you've protected the stuff, if your PRA stuff no longer becomes an issue. So it might be worth something that, although it's going the direction of conservatism, it protects your budget and your regulatory risk. That's it.
okay, thank you for the suggestion. But so to wrap up fire protection issue, is there? I know we have a lot of interfaces with EPRI. Fernando mentioned that. Is this something maybe we set up a meeting between the two of us and maybe talk about it and see what we can come up with? Okay.
All right, Brian, I do have one hand. Joy, I don't know if your comment pertains to fire or something else, but you should be able to unmute. Joy from the Breakthrough Institute.
Yes.
Oh, there you are.
Yeah, thank you. This is Joy from the Breakthrough Institute. We are a nonprofit think tank based in Washington, D.C., and I really appreciate this opportunity. So my colleague and I, we participated in day one back in 2025, and then obviously today. And I just want to leave one comment that I feel like the NRC needs to do more in terms of explaining how the PRA realism can be applied to the advanced reactors, especially microreactors, because I feel like that's where the disconnection is for a lot of public engagement, that a lot of questions and things are going being asked about, oh, how does this apply to advanced reactors? So I feel like maybe in the future, if you're going to do a similar workshop or similar public meeting, really think of this as more of not into the weeds, but high level public engagement, that you communicate clearly with the public. How does the PRA realism related to the advanced reactors, and why those conservatism doesn't work, or what are the changes that the NRC are pursuing? So that's just one small comment.
Okay, thank you, Joy. Okay, yeah, feel free to raise your hands as we go forward. Let's see. So back to I call it industry capacity to do more. This came up in the last meeting, the first day, particularly in the area of fire protection, I believe, because there's newer methodologies that we've come up with. But what we heard from the industry was that the PRA staff that they have are very limited in their time availability to do things like these special initiatives, to be able to implement those into their PRAs. And what was driving that limitation was the the 2-cycle requirement to do updates to their PRA. I guess the baseline update to their PRA. It's a requirement that they have to meet. It's something that we talked to NEI about following that meeting to get some more clarity on the issue. Victoria, do you want to say anything? I know you had proposed to take an action.
We've even before that, we've sort of been talking as an industry about is there something we can do to appropriately scope those updates? Are there things that we're doing as part of those updates that are not actually required and we just have been doing them out of habit and we think they're required? So we haven't formulated like a formal project or anything, but that's something we're internally talking about, like what could you do? And EPRI is also developing some products that make the mechanics of it easier. But I think in the meantime, if we can reduce the scope of what's in there and really take a hard look at, are we doing things that don't need to be done? We can make it less burdensome. There's really no way to get around the every 2 refuel cycles. Like that's in the regulations. So.
Yeah, Fernando Ferrante from EPRI, just to add. I mean, one of the things, if you look at the trajectory of where we've been, right? 20, 25 years ago when ROP was beginning to change the risk inform, right? I mean, PRAs were still not as uniform as they are today. We didn't have all the risk inform 56.9 text backs and things like that. So there's been certainly a trajectory, right? We haven't stayed, frozen without improvements. There's been significant improvements, right? True NFP to 5, true seismic, post Fukushima. And so one of the things that is coming up, and sometimes it doesn't sound as sexy in terms of technical work, but there is a significant pressure, right? And again, realism here needs to go back to, there is a cost, and that's not to say we shouldn't be realistic or we shouldn't spend the cost, but it's to say we need to be aware of where can we do things that are beneficial, or do we put them in the right swim lane if it's longer term research or expedite, right? Because one of the things, as you're saying, Brian and Victoria commented on, is we're getting very strongly that the burden of the maintenance is significant. And so that's important, and we should take it seriously because we want to keep these PRA models realistic and we want them to stay updated. And so the big question is, I think, the update process, and I'll speak to it from my point of view as EPRI, not as a utility or any other organization, but, my perception is there's a purpose for the updates. They are important. I am absolutely not saying they should not be updated or it's not important. I think the question that's coming up is before, an update of a PRA at a utility, it's a massive enterprise, as I've come to learn in detail, right? And again, not saying it shouldn't be done. It's a big weight on the PRA staff, and it's almost like they are updating, getting to a point, submitting applications, and then getting to another update, right? So it's kind of a constant, spinning wheel that they're going through, right? And so one of the things we did, and that issue is complicated because it's like, well, is it a technical issue? Is it the requirements? What's the problem here? What's causing an issue, right? And so one of the things we tried to do as EPRI is we went through a multi-year effort to try to identify in seismic PRAs, right? To take one example, when is new information indicating a change, right? Because one of the things that I think we've been, is part of what happens, right? We learn these things, there's an event, we learn things with just the generic issue 199, for example, and others. And so it's every time there's a new change or a hazard change, sometimes the reaction is, well, everybody needs to go do a full hog analysis. And sometimes you can begin to tell us, for example, some of the next generation attenuation curves changes, that you're kind of on the edge as to whether the change is really significant or not. And I think a fair question, right, again, to be fair in multiple directions, right? There is a question of something change, and without running it through an analysis, you don't necessarily know how much the change is. And so if a question needs to be asked of, is this change, short of doing a full analysis, significant, what will be thresholds that are reasonable to say, yeah, there is a change, but honestly, it's probably within the noise. That I think is the kind of update and maintenance is important. Probably because of the level of importance of the PRA models, their role in so many risk-informed applications, the fact that a change in a PRA could be a significant change across the board, including completion times, including, surveillance frequency control program, et cetera. I think understanding where the changes are significant and having a technically defensible argument to say they are or they're not, right? Not artificial, but something that says we know a change of this much usually doesn't lead to this. And so I think that's kind of the discussion we've engaged in. And we had some success with the size of the PRA. And the question is still lingering out there in terms of the cost and benefit. And I think reaching a level where it is properly updated and the realism includes considering new information, how much or how fast or how deep that needs to be changed, is something that seems to be where the PRA world has, at least particularly on the industry side, is kind of going. And realism matters there because we want them to be updated. We want them to stay realistic. And we want to reduce the burden of, say, documentation or arguing about things that are probably not going to change the numbers per se too much. But just my 2 cents of.
Hey, this is Jonathan in the Office of Research. So I think maybe I heard 2 different things. I'm just trying to make sure I understand. So were you all talking about what triggers an update in the standard, or were you talking about, say, as a part of the program that's incorporated by reference, like the risk from completion times program? Because I thought I heard Victoria talk about what's actually, okay.
I mean, in plain terms, Jonathan, the issue, we got into an interesting issue, which your question is fully related to, which is, well, I mean, it's not EPRI's role, right, to get involved with how often the PRA needs to be updated from a standard, say, JSON-RAM point of view or a risk-informed application, right? Each of the risk-informed applications have an update expectation and how often and so forth. So we at some point got challenged, and my reaction first was, EPRI's not going to say, well, you don't need to meet NRC regulations for updates because we think that the changes on, I don't know, CCF or initiating event frequencies or someone else are not that significant year to year. But so then we had to tease it out because we work with Victoria and the owners groups that are very closely related to the requirements and meeting the expectations. And we got the other question, which is the one I was referring to on the seismic issue, which is, well, what's technically defensible to say this is not a significant change? And the 2 are connected because if we have a technically defensible way to say, yes, the hazard, and again, seismic is just an example, hasn't changed that significantly, then is there something that can feed into the regulatory requirements or expectations that rationally and coherently says, because there's a technical basis, okay, we will accept that. Eventually, you might have to do the change, or if we might, as again the NGA East outcome is turning out to be, most likely shows that change is not significant, and so it's connected with slightly different flavors depending on who's involved and what are we being asked to do. If that answers your question, Jonathan, a little bit.
Yeah, I think that answers the question a little bit. I mean, sort of spitballing here, it seems like maybe the conversation should be brought up during the standards committee meetings. And as far as the actual guidance or I guess requirements per se themselves, I'm not really even sure how they even explore that except to maybe get like the licensing groups involved.
Yeah, I mean, the only thing about the standard is, well, that and the base models is what the standard particularly focuses on, right? There's all kinds of requirements and updates on individual risk-informed applications. And so I'm sympathetic to the standard trying to define risk significant, but risk significant depends on what are you looking at and what is the issue. And so I think, and they have a role to play, right? Absolutely. It's an essential role to play with a peer review process, et cetera. I think there's a technical question on what is a significant, and the risk significant item JSON-RAM is looking at is related to it. there's what is the basis? There's a programmatic aspect, right? What is the NRC's expectations? So the PRA models can continue to be met. And what is the right thing to do, right? I mean, we definitely don't want the update to become a realism problem. So.
Okay.
Was that more discussion than you expected there, Brian?
It was good discussion. So what led us into this was industry capacity to do more. NEI said that they were going to go off and consider that issue and may in the future make a proposal to us on the scope aspect of those updates, those 2 refueling cycle updates. So moving on to the next area that we want to touch on, external hazards. A couple notes that I have from there kind of goes towards conservatisms again, and what's utilized in the PRAs. I have a note on partial fragility correlation. And then are there certain assumptions within there that are external hazards that are over conservative? If there's anybody has any input on those.
Jodine, I see you have your hand up. You should be able to unmute. All right, give me a second. Let me try something else. All right, give that a shot. There you are.
Yeah. 2 things. One, on the 2 refueling cycle, I'm not sure I completely understand where the basis from that originally came from, but that's going to be completely different for a lot of advanced reactors that have 10-year cores and like that. So is that really the update scope that we're going to want for the advanced reactors, or do we need to look at something different from that perspective? It's just the first one. And the second one is like I was mentioning earlier, for some of these unique designs, the micros that you don't know where they're physically going to be necessarily, because they could be maritime on a ship, they could be, transportable, so they could be in one place one day and move somewhere else 3 weeks later. How do we handle the seismic, the tornadoes, and like that? Because depending upon where they are, it's going to be completely different. And is there a way we can look at I don't want to say bounding, because I don't know how you'd ever really bound it, but we also need to start considering 3-dimensional stuff if we're looking at maritime because of waves and stuff like that, which is different than what we have for land-based reactors. So it's something just to throw in the thinking pot when you guys start looking at these unique applications.
Yeah, thanks for the insights there. So one of the concepts that they're looking at for these reactors, and it's been utilized in the past, and the design certifications for the light water reactors are plant parameter envelopes. When you review a design of a facility or a design, they will put those bounds within there. And so when we do our review and issue the approval for those designs, it's only for those parameters that they had provided to us as part of the application. If in the future somebody wants to utilize that design at their site, they have to evaluate it against those plant parameters. And if it exceeds those parameters, those have to be addressed in the application to us. And so that's essentially how the process works now, and how it would work in the future as well. It's being addressed in Part 53, potential new Part 57. So some of these newer reactors, like you say, they will have cores that last a lot longer, as you say. And some of the approaches being considered for these advanced reactors may not include PRAs. There may be other risk analyses that they may be allowed to utilize. So a lot of that is still being worked through now and further in the future. From back to external hazards. I guess this is similar to fire protection. Is there a way to identify some of those conservatisms that we might be able to address some of those in a more nearer term fashion? I don't know. Do you want to add this to the list, Fernando, for the meeting with you all? Okay. All right. Okay.
Sunwoo, go ahead.
Yeah, this is a Sunwoo. I gave a talk on seismic PRA realism on day one in September 30th. And Brian just touched upon partial correlation for seismic, a common cause of failure. Yeah, I mentioned that that aspect as part of my presentation. The usually the common practice that I know is that since the exact correlation ratio of a seismically the initiated seismic initiating event, there is a tendency that people choose either full correlation, which is 100% correlation, or zero correlation. And the actual, the physics-based correlation should be between 0 and 100%, which is called partial correlation. But I understand that due to the lack of information or data, with that lack of information is a driver for people to choose full correlation or zero correlation, more toward the full correlation, which may result in more conservative results. So I'm not an expert in this area, but I understand if partial correlation, which is more realistic, that will require more data collection, either from research through testing or from collection from the actual earthquake experience data with the nuclear power plants or with the comparable industry facilities. That's my view.
Okay. Thank you very much for that. It's similar to other areas where there's a lack of data. Digital I&C is one that we're going to touch on shortly. Okay. Next area I have is human reliability analysis. Aero Commission was brought up. More data collection. How do we do this? Dependency model was discussed. I know that we've had one for ideas dependency that's been out for a few years now. We recently put it out for, or we requested public comment on that because we didn't do that the first time around. And what we'd like to do is get that public comment and then issue the document as a new reg as opposed to a real. So looking forward to public feedback on that part of our model. Ideas recovery is another thing that we're working on. I think there's a meeting with EPRI. Is it EPRI this month, excuse me. Whenever we're going to make a little presentation on that. So we're working in those areas. How can we go about collecting more data for human reliability analysis? I know we have our Cicada program. We had one licensee utilize that. 10 plus years ago now. We were able to get a lot of good data from that. But we haven't really had any takers on that since then. Obviously, the more data we have, the better results that we can get and utilize going forward. I know we have some interest. I think South Korea is interested in using maybe Cicada. I know we had one advanced reactor company that was interested in doing it, but I think that kind of fell through as well. But if there is any utilities that might be interested in that, we'll be willing to work with you on that. Get Fernando on one.
All right, let's get Fernando a mic, and then I do have a hand that I'd like to get to. I'll come around.
Fernando of EPRI, just a couple of thoughts on, the HRA dependency was an important thing, and it's a good example of realism issues because it is model in current PRAs, right? And again, it goes back to my comment on the burden of the modeling. We kind of started backwards. The dependency is kind of like CCF or human errors type of thing. And so we kind of started with, okay, we know there's a dependency, and historically we started to kind of add it post development of the model. And that ended up with some models that the utilities have with like thousands of dependencies that had each to be accounted after the fact, putting into the model. And that, of course, created a major issue when you change something in a model and then all those dependencies could become completely out of sync. And so it was a maintenance problem. It was a realism problem. There was overcounting or double counting in some cases. And so one of the things EPRI tried to do here, and I think the idea is another aspect that is advancing that, is how do we put the modeling to be more upfront? And yes, it does cause some challenge for people who already have one way. Is it worth doing it the other way? But how can we put it upfront, focus on those coupling mechanisms a bit more, and then making sure we do it realistically, right? It's not about getting rid of dependency or justifying extremely low numbers. It is about putting it in the right place with the right level of realism and in a way that is managed by the model. And so that's a good example. And it's a bit backwards already kind of happening, but it's a good example of the kind of realism I think is still out there in terms of other issues and how to tackle some of those. I think the digital NC HRA aspects are still out there. I think to Jodine's comment, advanced reactors are now going to have a myriad of operator engagements with this new designs. And so realism, there's some gap there in terms of the realism. Errors of commission is the one that it's kind of like the cultural organizational aspects. Interesting, but are we ever going to close that gap completely? No, because, again, this is a very good discussion on what is realism for PRA and does it make sense to go after more realistic things, right? Errors of commission begin to create some bounded situation where people kind of challenge PRA for not having everything under the sun that can happen, which I'm sorry, I don't think any engineering discipline knows everything that can happen. And so you're asking the PRA to do something that it cannot do and other areas don't do. But if we start saying, well, what if the operator doesn't feel like following the procedure? What if they do gross negligence? Well, yeah, you can put that in the PRA. You're going to get bad numbers. But is that meaningful? And how many combinations? I mean, at some point it becomes explosive. And so that's where we got to put the realism context. But I'm going off on a tangent here. I think for HRA, there are some very interesting aspects to look into. I think some of the tools now need some runtime to figure out where, how much more and where there could be benefit from improvements. But HRA, as long as we have operators involved in the nuclear enterprise, we're going to be doing some kind of realism improvement. So I think that's just my comments, Brian.
Ms. Miller, if you wanted to unmute and provide your comment or ask your question at this time.
Yeah, I wanted to bring up that with some of the newer digital systems being installed, we're getting initiator events from the industry over the past couple of years that have to do with the interface of the digital system with the humans. And some of them are upstream where there's latent software errors, and others are more downstream where, for example, the conduct of operations, Surrey took a point out of scan and the turbine tripped because that signaled to the turbine it needed a trip. And Vogel 2, I believe there was a disconnect between the runback procedures the operators were using and the runback methodology the software used. And those are just two examples off the top of my head. But at the point where we're getting noticeable events from the humans interfacing with the digital items, it's probably time to look and see if our probabilities of something happening, whether it's latent or actively during use of the system, the numbers are already showing a lot higher likelihood of initiating events than what is originally assumed in the PRA. And this seems to be correlated with new digital systems being put in. And of course, the rationale that says, well, because we can't test every possible permutation, we won't test we'll only test a certain number of them that we can anticipate. And so it could be that although testing is a way to mitigate what might be embedded, there's probably a need to adjust for just how much PRA difference the human interfaces are with digital systems, both upstream in the software programming, as well as during use where procedures meet the digital items or the conduct of operations meet the digital items. That's it.
Thanks. Good information there. I don't know that we have any of our human factors folks on the line or in the room with us, but I know that we have been doing some testing in this area, actual human testing on some simulators, both in our own simulator here, small one that we have as well. I think Halden HTO is been doing some related testing as well and putting out some reports. We do have some plans to do additional testing in this area. Some of these have to do with like touch screens, use of digital procedures, different aspects of that, even different types of screens as to get better. Anyway, but like you said, looking at the data of actual events versus what we're assuming. That's kind of an ongoing thing that we should be doing and monitoring. Oh, Jing, you want to chime in here?
Yes. Jing Xin, Office of Research, and working for branch division. So just some additional information on this. We just released published a new reg CR. I'm sorry, I forgot the number 66734, and the number may not be wrong. It's on managing human performance with degraded digital ANC. So that's I would say that's a combination of human factors and approach and qualitative HRA approach. Look at what are the possible degradation and how those digital ANC degradation, specifically the interface, how they would affect human performance and how human performance can be managed under such a circumstance. So, and April was just learned that April is going to give us some comment on that report. We're probably going to have more discussion on possibly how to incorporate the information into the HRA PRA domain. And we also have started collecting, look at digital ANC event and analyze them document them with ideas model. So that's a continuous work. Yeah.
Great. Thanks, Jing. Okay. Well, you guys are going to discuss HRAs. Was it next week? Okay. With EPRI. EPRI's having a meeting. So digital instrumentation and control. So maybe just touched on that a little bit. one of the notes I have here is utilize other industry data for reliability, OPI. Are we aware of other sources of OPI related to digital INC? FAA, maybe? I don't know. Planes?
We looked into that a couple of years ago as part of a research request. There were some research studies internationally that had postulated digital INC. This was related to common cause. I guess I'm sorry. Were you talking about common cause or just in general?
Kind of in general.
In general, we haven't really, to my knowledge, I don't think we have found anything beyond even what we have in the plants right now is non-safety systems like feed water. So we're trying to limit it to nuclear. We're pretty confident we can get enough information going forward from the nuclear plants. The IRIS database is set up to capture digital INC information and failures, and so we're hoping, we're actually ramping that up right now to try and use the information that we have from operating plants. So we haven't really gone beyond that to like FAA.
Fernando Ferrante with APRA. Yeah, that question has come up a number of times, Ryan, and a bit about PRAs. Sometimes you add more data and you don't quite get more insights. You get more uncertainty. But the perennial issue of other industries is always, are the same. Is this the same boundary conditions? Is the, I mean, the classic saying is something happens with Boeing or somebody else, and people say, "Oh my God," And so, and it's a fair question to say events are happening, and I think the first thing to ask is, what is the digital component? Is it a software issue? In every event in oversight, there's always multiple facets to the causes of some root cause, right? Is a fair question. And the question with the boundary conditions, right? Like the military, for example, at some point we looked at how they deal with flex-like data, and the contexts are often different. The boundary conditions, the level of resources, the applicability, the qualification, and that's not to say we shouldn't look at it. It's just to say it's a valid question, and the level of understanding the data and the applicability and the insights that come of it is what needs to happen. I think one of the things, to John Lane's point, is we're working with the Koreans and the Chinese who have done a lot of digital INC implementation, and they are probably our closest source of data and insights in the sense that they're using similar nuclear designs with operators and with actual runtime and data that at least has some level of pedigree and connectivity to what we're doing here. There are some insights in other industries that are always interesting to see. And the question there is, what is the role, meaningfulness, and applicability to what we're doing? And so it is an area where realism is definitely going to continue to need some improvement. And I think, again, not to say against looking at all the data, just a caution on how we do this, which I think is the right way to think about it.
So I think, well, from this perspective, we'll kind of continue to monitor and kind of look for other sources as we can. So, all right. So those were my notes that I had from the first day's worth of topics. I don't know if anybody else had any additional things they wanted to add from the first day. I only have a couple of things from today. Walk on. It's all right. I'm getting my steps.
Just one question, and I feel like I asked this the first day, but I apologize if I'm repeating, or if it was said earlier this afternoon. The level 3 PRA project, right? I mean, I'm just not going to ask a simple question. There's a lot of work that went into kind of coming up with, the next kind of NUREG 1150 update on what is a modern state-of-the-art PRA model do? So as that concludes, I mean, does research have a sense of where that exercise could provide realism insights or how to leverage those insights? Is that something that is connected to our discussion here, or just wondering?
So this is this is Jonathan Evans, Office of Research. So now that we're finally concluding the project, we're starting to look into that, and I do believe that probably within the next year, once the final volume, the summary report gets released, there will be some conversations on the insights that we've got. The plan is to start internally doing a roadshow, but then from there, starting to reach out externally to everyone else to look at what we've learned and what we can do with that information and what sort of goes beyond.
We also looked at how we can utilize that information and apply it to the operating fleet. And we made some recommendations to NRR on that. For now, from a prioritization standpoint, that's been put off for a while. Hopefully we'll be able to get back to some of that in the not too distant future, resources allow.
I feel like it's a great opportunity and it was a great word. So once it completes, it's like a template to say, what are these realism issues and how does that help, right? Especially because it has a level 2 and level 3, which, again, just like the SORCA studies, they cannot just be generalized for everything. But given that that's our next benchmark on what a realistic PRA model looks like, I feel like there's a potential there.
All right, from today, so we went over SDP, Accident Sequence Pursuer Program, RASP handbook that we've issued a somewhat significant revision to. I know most folks may not even been aware that we issued that right before the holidays. And if you were aware, you probably haven't really looked at it much. With respect to that, I don't know if we need to go into it very much. Chris kind of hit the highlights of the changes that were made. Once you take some time to look at it, if you have questions, concerns, suggestions for future improvements, I guess, let us know. We can talk about that. But I guess this was the first time we've did a major revision to it in quite a while. So, and I guess related to that, Victoria, in your presentation, you talked about the SDP, and obviously RASP is used for SDP. You talked about scenario-specific focus and conservatisms. One area specifically is when, or a common cause failure, where the issue was not, well, the way I characterize it, was not generic, in that it was like a component specific and not applicable to other like components in the plant. How we might be able to address that when doing that site-specific evaluation. Is that something that you think we need to prepare some type of guidance on, or for the SRAs in the future?
I think in that meeting that Chris and I talked about, that's probably something we'll cover.
Okay. Oh, well, common cause failure. Okay. All right. Okay. And then Fernando, you talked about defense in depth and safety margins. I was wondering, and the way I characterize it is, or I copy down what you wrote, defense in depth and safety margins, how they support or help PRA activities and RITM activities with less of a focus on PRA. And you specifically mentioned materials issues and digital INC. Is there something you think that needs to be developed in that area?
Yeah, Fernando Ferrante of APRI. I mean,
it is The thought that came to mind for me was Red Guide 1174. I don't know if that would be a place to.
Yeah.
address it.
So, one of the things I think, or at least a few areas, right? I presented kind of the overall ideas because I didn't want to get too bogged down on anything. Then scope creep comes in. But I do think, again, this is about as we expand the user risk, as the risk smart, graded approaches, graded licensing reviews. I forget the licks, but there's licks that provide different layers. As now there's been a discussion recently on power uprates and how risk informing those areas can be with some sense of the framework of what the buckets will be. I think there's something there. What exactly, I don't know. I will think, we were discussing some materials issues last year regarding piping. And I sense a very strong need to align what do those things mean, with the staff that understands piping, with the risk folks, and how that conversation needs to go. And I think what I sense from the discussions we had is that there was a reasonable question to understand, right? Not to say we disagree or agree or this particular licensing action should be approved or not. I think there was, above everything, an intent to really understand what is in the PRA, how does it impact folks that don't use it every day, but they look at the materials issues, they look at fracture mechanics. There's a question, for example, now that things like XLPR are used, including in some LIC 504s and others. What is that role, right? The PRA people don't do probabilistic fracture mechanics. And I think there was a confusion that PRA and PFM have probability in there. So, of course, the PRA people must know about it. Well, that's not the case. And I think there's a fair question on, well, what is the implication as we refine some aspects, as some actions looked at refocusing or reshifting where inspections need to happen. There was a good question on, well, if you're doing less here, why is that appropriate? What is the basis? And how do we prevent new material degradation mechanisms or kind of the unknown unknowns comment from happening? And I think a lot of those, at least in my opinion, were alluding to the view of defense and def treated a certain way, and now bringing information from a different source with probabilistic elements to it, and how do we gel that? And so I do believe there's a discussion to be had, and it's kind of a bridging discussion between communities. So that, in my view, it's not about telling them they're right or they're wrong. It's about having that, airing out those discussions on what's in the model, what do you have confidence on, what are your expectations, and how does it fit on the risk-informed decision-making or just decision-making? Digital NC is a long-standing one. I think we are having discussions. There's an ongoing activity on that. Another one is, there's a lot of work going on increased enrichment and power uprate. And I keep hearing the words risk-informed. And one of the things I always ask when I hear that is, do they mean what I think they mean? And what do they exactly mean? And are we talking about the same thing? And so I think there is room for, under specific scenarios, there's risk-informing LOCA, risk-informing certain fuel issues. I think there is cross discussions that need to happen. It's not about teaching people PRA or forcing risk-informed down their throat. It's about bringing the level of confidence, because at least from my opinion, that's where some of the questions are coming from. And I think they could benefit. I mean, again, this is not about convincing people on what the action needs to be. It's about having a better discussion and making sure there's confidence in what's being presented, rather than lack of confidence, distrust, and then potential outcomes that do lead to some angst in outcomes and the efficiency of the discussions. I think there's been a lot of movement and improvement. And so if there is something there, it might be discussions as to what in this area, what does that mean? And how do we bridge the fact that we are now putting multiple probabilistic type of content into it? Anyway, those are some of my thoughts, Brian, off the cuff.
Yeah, I was in some of those meetings several years back with respect to the piping and the extending of the inspections and performance monitoring and such. So, okay, so I'd have to talk to the folks in those areas about setting up a meeting similar to that and pass this on to them. So let me see if I had anything else. Okay, nope, I don't think I have anything else. Those were the items that I had come up with during the first day and today. Does anyone have anything else they'd like to bring up? Any additional areas they'd want to talk about?
All right, I usually say speak now, or it's not a speak now or forever hold your peace kind of thing, but it is 4:25, so we're close to our end time. So I'm gonna say speak now or at least hold your peace to the next meeting. How's that? Looking for anybody raising their hand online or anybody raising their hand in the room.
All right, well, guess I'll wrap us up then. I thought these discussions today and the end of September were really good. It highlighted a lot of the areas where we are making progress on realism, areas where we're actually working together to do that. Well, I guess we identified a couple areas where things could be done better. We're going to set up a couple of meetings to get into some specifics about things we might be able to address going forward to help improve things. Appreciate the members of the public attending and providing input as well. And for those of you in the room, thanks for coming back for the second day. Some of you had to travel for that, so I'm really appreciative of that. So thank you for all the discussion and the questions and the suggestions. So thank you very much, and we're done.